Hello, Mishra sir. Good morning.
Yeah, ma'am, you can start. I'm here.
Yes, sir. Yes, sir. Here is Dr. Swati Bisiket. We will start now.
Yeah,
Yes.
please start.
Pranav sir.
Yes, ma'am.
Hi. Yes. Please.
A very good morning to one and all. I, Pranav Chippalkatti, on behalf of JSPM's Rajarshi Shahu College of Engineering, Department of Electronics and Telecommunication, heartily welcome you all for the first session of Day 6 of Phase 2 of 2 weeks Faculty Development Program on Artificial Intelligence and its applications in Biomedical Engineering. Today we have with us an eminent speaker, Dr. K.K. Mishra sir, to deliver session on topic binary genetic algorithm and its applications and classifications. On behalf of ENDC department, I heartily welcome you, sir. I feel extremely honored to introduce him today. Dr. K.K. Mishra sir is presently working as an assistant professor in Department of Computer Science and Engineering, MNNIT, Prayagraj. He has successfully organized around 6 IEEE conferences in India, IEEE series as a conference secretary and worked as a program chair for many other conferences. He has worked as PC members for many conferences in India and abroad and has successfully organized some special issues in highly indexed journals. He is a regular reviewer of Journal of Supercomputing, Springer, Applied Intelligence, Applied Soft Computing, IEEE Transactions on Cybernetics, IEEE System Journal, Neural Computing and Applications and IETE journals. In addition, he has reviewed many publications for SCI and Scopus Index journals. We are fortunate to have you with us today, sir. I welcome you once again and request you to start the session. Thank you, sir.
Thank you, Pranav, and thank you, organizing team, for inviting me for this lecture. So my lecture, I'm just sharing the screen. Hopefully, you can see it. Uh, are you able to see it?
Yes, sir. Yes, sir.
Okay. So today I will talk about one application of artificial intelligence. Actually, I will discuss various application of artificial intelligence, and I will discuss one algorithm which is related to artificial intelligence, and then I will show how that algorithm can be used in solving classification related problems. So, because we want to work in artificial intelligence area, so we must know like how it is different from other programming techniques. Like what is the difference between traditional program and artificial intelligence program? So artificial intelligence is a branch of computer science, because we need to differentiate like what is artificial intelligence and what is there in computer science. So we have to start with this. It is a sub branch of computer science which deals in designing smart machines which are capable to do all the tasks which requires human intelligence. Actually, we write programs because we want to solve problems. So there are two kinds of programs which we want to use. Uh, in most of the programs, we want to solve sorting, searching, these kind of problems. So those problems doesn't require any intelligence. But if you want to recognize the face of a particular person, that it requires intelligence, because you have to identify the gesture of that person, the facial expressions. So in artificial intelligence area, we want to study, means how to write those programs which requires human intelligence. So AI techniques, it is not only one technique. Actually, it is a combination of several techniques which are used to solve these problems by computer. Means we will be writing the programs for solving some problems which requires human intelligence. So there might be several techniques. So solution of such problems require implementation of human intelligence in computer program. So why programming in AI is typical? Because here you have to solve those problems where you need human intelligence. So how will you implement human intelligence in computer program? It is an important issue. So that you have to resolve. Let us see what is the difference between computer and human being. So initially, a computer was invented to speed up arithmetic calculations and data processing. So actually, arithmetic calculation, like if you want to add two numbers, so that if you are writing that kind of program, that is very efficient for computer, because computer has both hardware and software which is supporting such kind of calculations. Data processing means string processing. It was never created for replacing human beings. So initially it was invented to speed up arithmetic calculation. It was not created for replacing human being. So that is the difference. Its hardware and software has certain limitations because we want to do computations, right? So we have created hardware and software which can support these computations. So if you want to solve any problem using computer, what you have to do, you have to create a mathematical model. So that mathematical model is called as algorithm, which you have to implement in certain programming language. So who will implement that mathematical model? So for implementing that mathematical model, you need a human being who will be the programmer. So that was the idea behind computer, how computer was invented. But what we are expecting from computer nowadays, we are expecting that the computer should replace the human being. So what should be what we are wanting from our computer nowadays? So we want to write a program. We want to make this machine intelligent. Intelligent means it should behave like a human being. By writing programs, so definitely the only thing which we can do in computer is, or whatever programming we want to implement, actually we can do it through programming only. So we have to write programs which can make this machine intelligent. So how can we write intelligent program? So there should be three characteristics of a computer program. First is it can automatically convert any problem into a mathematical model which can be handled by the computer hardware and software. So let us suppose if you want to write a program for face recognition, okay, you don't need any expert, like how that face will be converted into pixels and how those pixels will be converted into array. So that will be taken care by your machine. Initially, you require a person for converting these things. So if your machine is able to do these things, then your machine will be a smart machine. Moreover, in some problems, you may have more than one solution for the same program. So your program, like your computer should be able to pick the best solution. Best solution means which can produce the result in minimum time. So there are many problems which where you may have many solutions. For example, if I'm moving from Allahabad to Pune, there might be many paths. So what will be my goal if I want to uh, choose the best path, then I will choose the minimum path with the minimum distance, and automatically adapt according to the environmental conditions. It means sometimes actually when the condition changes, the output may change. For example, if you are having a automatic uh, air conditioner in your room, if the temperature is changing, it should automatically adjust the temperature. So that kind of thing we want to implement. So that things actually make your program intelligent. So what kind of programs, like what kind of problems we can solve using artificial intelligence techniques, like where we can apply artificial intelligence related programs. So first problems are optimization problems. So in certain problems, you want to identify minimum or maximum value of an objective function. So those problems are called as optimization problem. Second kind of problems are prediction problems. I will show you some examples so you can see like what what are optimization problems, what are prediction problems. So in prediction problems, we have to predict either the correct class of a given on a given input, or you have to create a mathematical function which can give the correct output based on certain inputs. Expert systems are used to implement domain knowledge which are essential for an expert. For example, if we have fever, then we have to go to the doctor because doctor is having a lot of information about a specific field. So if we want to replace expert system, means we are replacing some expert. Similarly, natural language processing means we want to make our computer intelligent so that they can directly communicate with the human being. So initially what you are doing, if you want to establish communication with the computer, you have to write program, then only you can establish it. But people are actually searching different ways to directly communicate with the computer. So let us suppose if I am speaking, you can see like Alexa and other devices are available now where you can speak and they can understand what you want. So that is the part of this NLP. So where you can apply, what are the application areas of optimization problems, like where you can find these problems? So there are several domains. Electrical engineering, there are some problems which are related to economic load dispatch problem. In mechanical engineering, you can uh, fix some parameters for maximizing the production. In management, portfolio optimization is a very good problem. In electronics, you can go for signal processing. So optimization is everywhere. So where if you want to optimization, if you want to optimize certain function, then you can use optimization algorithms. Similarly, for prediction problem, as in electrical engineering, if you want to forecast the load, then load forecasting may be the problem. In mechanical engineering, you can create a supply chain and you can predict the demand. In management, you can use your machine learning techniques and you can give some idea about stock condition. So that is called as stock market prediction. In environmental science, you can predict what will be the temperature uh, on next day. So there are lot of application of prediction related problems. Expert system, where you can use expert system. So in electrical engineering, you can use smart grid. Smart means it behaves like an expert. So some information will be stored in your grid so that it can automatically take some decision. Similarly, you can create a smart supply chain and a smart portfolio management system. So that you can do only by designing the expert system. So similarly, NLP, natural language processing. This is natural language processing means it is always related to how we are establishing communication with the different machines. So that area it is everywhere. So how should we write artificial intelligence related programs, right? So that is the main idea. So whatever problem you want to solve, actually artificial intelligence related problems are not easy. So they are always complex, right? So if you want to solve any artificial intelligence related problem, you have to study the problem in detail. So when you study the problem in detail, you will find some domain knowledge. Domain knowledge means something which is related to your problem. Domain means, so right now you are studying problem. So if you are getting some knowledge, so that is called as domain knowledge. So if you are writing intelligent program, then you have to use domain knowledge to identify solutions. because you need to design a mathematical function which can provide the solution of the problem. So in artificial intelligence related problem, the solution can be designed only after studying the problem related information. So that is always required. Then because you want to create a program which will produce different outputs at different time. So that is called as adaptability. So you have to identify adaptable parameters and models which can adapt according to the environmental conditions and can produce acceptable solutions. So that is important. Adaptable parameters and models. So for example, if you have a automatic air conditioner in your room, so what you will expect from that automatic AC? So if the temperature is rising, right? If the and temperature of environment is rising, it should decrease the temperature, right? So if it is not correctly programmed, then what will happen? If the temperature is rising, it will start increasing the temperature. So that is not good. So you have to produce acceptable solutions because you are writing the program, you are understanding each and everything. So acceptable solution is always required. So in case of more than one solution, you have to print, your machine will be able to identify the best solution as early as possible. So these are the things which are required when you want to solve any artificial intelligence related problem. So we will talk about like how can we solve optimization problem, and because optimization problems sometimes they are open problems, sometimes they are hidden in other problems. For example, sometimes they may be the those problems may be directly available to you. So for example, if you want to solve, let us so I just want to show you some example. Let us suppose if this is the function.
अरे ते घासायला ठेवलं होतं मी ओट्यावर आहे ना
So let us suppose we want to maximize the value of this function, and the
घासायला
value
दिलं तर
of
घासलं नाही
x is in between 0 to 3. So this is direct problem, right? So here you have to identify the maximum value. Am I audible?
Yes, sir, you are.
Okay. So this is a direct optimization problem because the function which we want to optimize is directly available. So we want to identify the optimal solution which can produce maximum value of this function. So this problem is directly available. So this we can call as direct optimization problem. Sometimes you will not find that optimization function directly. Sometimes it is hidden. Let us suppose if you want to predict something, then it will be the optimization problem will be the part of the prediction related problem. So we can use two methods for solving these problems. If we want to solve this problem, we can use two methods. One is we can write deterministic programs, or we can write randomized program. Deterministic programs means we can design simple solutions. Actually, most of you, I think, belongs to electronics. So deterministic programs means whenever you are writing a program, it should run in finite time. If it is running in finite time, then it is called as deterministic program. And other program, sometimes you cannot write deterministic program for solving some problems. So in that case, you will write randomized programs. So in most of the times, we write a randomized program for solving this optimization problem. So one example algorithm which is used in solving optimization problem is called as binary genetic algorithm. So actually, it is a randomized algorithm. Binary means it works on binary values. Genetic algorithm means its idea was taken from evolutionary theory of survival of the fittest. So that's why its name is binary genetic algorithm. So it will accept solution in the form of binary number, and it will implement the theory of survival of the fittest in our computer program. So that's why it is called as binary genetic algorithm. So we will study something related to binary genetic algorithm. So what is genetic algorithm? So it works on the theory of natural selection and evolution. This is a very standard theory. So actually it is an artificial intelligence related program. So I already told you that if you want to solve some problem using artificial intelligence related techniques, so most of the time you will be implementing the biological methods in your computer program. So GA was invented, or GA was created by mapping the theory of natural selection and evolution in the form of computer program. So why we are implementing this theory, and how the theory is related to optimization problem, that is a very good thing. So first we need to understand what is there in theory which motivate us to implement this theory for solving optimization problem. So this theory states that all species produce their offsprings by participating in natural selection and evolution. So actually this theory was given by Charles Darwin, and this theory says that if you have some four individuals, let us suppose at time t, so natural selection and evolution process says that they will go through selection, some kind of selection. We don't know what is the type of that selection, and after selection only some will survive, and those individuals which are surviving individuals, they will perform crossover and mutation, and they will produce new breed. So what is happening actually, from the parent population, offspring population will be created. So what is important in this one? The only thing which is important is here in this theory is, if the parent will be producing offspring, the fitness of offspring will be better than the parent. It means if you evaluate this solution, then this solution will be more fit as compared to this one. So it means what is happening, by implementing this theory, we can automatically move to a solution which will give you the optimal solution. So what we have to implement the same thing which was there in the theory in the form of computer program. And when you apply this theory again and again, you will get new solutions with better fitness. And when you repeat this process, you can go for the maximum value. So this is another kind of method which is very suitable for solving optimization problem. So what is important in this phenomena? The idea says offspring will have higher fitness as compared to parents. So it means without doing anything, if we can implement this phenomena, we will be able to generate new solutions which will be having higher fitness. So that's why we will be implementing this theory in computer program, right? So let us see what is binary in binary G. I told you, because it is implementing the theory of natural selection and evolution. So, and what theory of natural selection and evolution says, it will be working on some individuals. So those individuals are the solutions, right? So in binary GA, we will be representing those individual as a binary number, right? So that is called as binary. So that's why this is binary GA. So how we can implement the theory in the form of computer program? So let us suppose if we want to solve this problem, this is very simple problem, x square upon 1 plus x square, right? And we want to maximize this. So, and your value is in between 0 to 3, let us suppose. We are working with the same value. So here you can see this is the solution set. We want to identify the optimal value of x, which can produce maximum value of this one. But here we are representing our solution as a number. We don't know. Like it may be 0, it may be 0.1, it may be 0.2. So if we want to identify the best solution, what do we have to do? So we have to write the solution and then we have to evaluate the fitness. Fitness means what will be the value of this function at that point. So let us suppose if I'm taking 0, so the f0 will be 0. If I'm taking 1, some value will come. Now, if we want to implement the theory of binary genetic algorithm for solving this problem, okay, the first thing which I have to remember is we have to represent each solution by a binary number. So this kind of representation is not acceptable. We have to represent each and every solution by a binary number. So means if you want to represent solution by a binary number, then you have to divide your search space into 2 to the power n number of solutions. Why 2 to the power n number of solutions? Because when you divide it into 2 to the power n number of solutions, then every solution can be represented by n number of bits. And we have to represent our solution as a binary number. Let us see. So first we have to see what is the search space. Then we have to divide our search space into 2 to the power n number of solution. Why? Because we want to represent the solution by a binary number. So let us divide, if we divide our search space into, okay, 16 number of solution. Just wait. Okay. If we want to divide our search space into 16 solution, what will happen? The first solution can be represented as 0, 0, 0, 0. Come on. And the last solution can be represented as 1, 1, 1, 1. So that idea is you have to divide your search space into 2 to the power n number of solution. Then what will happen? After dividing the search space into some number of solutions, you have to pick some random solutions from those solutions, and that will create your parent population because you have to map the phenomena, right? So in most of the cases, because the problem which we are dealing is always complex, so the initial solutions which we will be selecting will be around 50 in most of the cases. Because here I'm explaining you with a simple example. So I'm taking only 4 solutions, right? So out of these 16 solutions, I will choose only 4 solutions as a parent population. So how those solutions will be chosen? So you will apply a randomizer and you will choose it. So from the initial set of solutions, I will pick 4 solutions randomly. So this will create my parent population. So this is done now. Now what we have to do, we have parent population. So then we have to apply the theory of natural selection and evolution. So how the theory can be implemented. So you have to apply 3 operators. One is selection for selecting good solutions. Second one is crossover for producing new solutions. And the third one is mutation. So crossover and mutation is used for producing new solutions, and selection is always used for selecting good solutions. So here you can see we have taken 4 solutions, right? So out of these 4 solutions, we have, when they will go through selection, only some solution will be selected and others will be rejected. So how we will implement those things? There are several selection operators which are already there in genetic algorithm. which we can use for implementing selection. I will tell you one example. But before that, you need to understand like how the like which solution will be selected and which should be rejected. So definitely we want to select those solutions which are good in terms of fitness. Good in terms of fitness means you have to calculate the value of fitness value of these solution. But these solutions are represented in binary. And earlier I told you that we want to solve this problem. This was our problem, or any function may be there, right? And this is x. The value of x should be in decimal number. So if you are representing your solution as a binary number, right? But your actual solution is in decimal. So how will you calculate the fitness? So definitely some method will be required to convert this solution into the exact solution. And then you can evaluate the fitness value of the solution. So for calculating the exact value, you will apply this formula. So this is, let us suppose if we want to calculate what is the actual value of 0, 0, 0, 0. So this formula will be used. X minimum is, because your search space was in between 0 to 3. So X minimum will be 0. X maximum will be 3. So you will be using this formula 3 minus 0, right? 2 to the power n means how many solutions you have taken in this search space. So that was 16, then minus 1, and then the decimal value of x binary. So that will be 0, right? So when you calculate this value, it will give you the exact value. Similarly, if we want to identify what will be the value of 0, 0, 1, 0, we have to apply the same formula. So that will be 0 plus 3 minus 0, 16 minus 1 into this value, 0, 0, 1, 0 value. So 0, 0, 1, 0, 0 is 2. So in this way, we can calculate the exact value of these solutions. So once these values are calculated, then you can calculate the value of fitness function. So let us take one example. So let us suppose if our input domain is 0 to 3, means the value which we want to search is somewhere in between 0 to 3. And the number of points we are taking is 64. Means we are dividing this search space into 64 number of points. Then what will be the value of this binary number? So we will be writing x minimum is 0, x maximum is 3. Total number of solution which we are taking is 64. So we can calculate the decimal value, actual value. So this is how we can calculate the actual value. This is another example. So same thing is created. So after this, let us suppose we have taken this one, this parent population. This was 0, 0, 0, 0. This 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, and 1, 1, 1, 1. So this was our parent population. Now we have to apply the selection. So before selection, we have to calculate the fitness. So that was 0. Let us suppose we have already calculated the actual value of these solutions, and we have already evaluated the corresponding fitness. Let us suppose this is 0.2, this is 0.4, and this is 0.6. So these are the fitness values of the solutions. So what selection says? Selection says only fit individual will survive. So how will you define fitness? So fitness will be defined on the basis of fitness function that you have already evaluated. And what do you want to optimize? So optimize means you want to maximize the value of this function, right? So definitely these two solutions will have higher fitness as compared to 0.2. So when you apply selection, some solutions will be selected and means fit individual will be selected and unfit will be rejected. So I will show you this one with the, let us erase all the things. Yes. So this is 0000101010 right? So and the fitness is 0.2, zero point 0.6 and 1. Let us suppose we are not concerned like how we are calculating fitness and everything. Let us assume that all these values are available. Now there is a selection operator which is called as tournament selection. So tournament selection is a type of selection operator which will select good solutions from this parent population. So how the selection will be performed? So randomly means you will repeat this process four number of times because your parent population has four individuals, right? So initially means every time you will be selecting two solutions. So this is, let us suppose first time 0000 will be selected and second time 111 means these two solutions are selected first time. Then you will check the fitness of these solutions. So this is 0 and this is 1. So which one is fit? So this 1111 is fit. So it will be selected. Tournament selection means because it is having higher fitness, only this solution will be selected. A tournament is played between these solutions and better one or selected solution will move in the intermediate population. So this will be selected. So next time, because you are using a randomizer, different set of solution may be selected. So 0010 and let us suppose 1000. So which solution will be selected? So you have to evaluate the fitness of these solutions. So it will give you 1000 will be selected. Next time when you choose, let us suppose 0000 will come into the picture. So and second solution is this one. So 0010 will be selected and 1111 will be selected. So you can see when you check the solutions, 1111 is repeated two number of times. So it means one has removed one solution with uh, bad fitness has removed. So that 0000 has removed from this one. So this is how the selection will be implemented. Several selection operators are there. So if you want to study, you can see the literature. So after selection, you have to actually exploit the area. So you, let us suppose I will show you something. Just let us suppose this is the function which we want to optimize, right? So what we are doing actually, initially we are selecting some solutions from the search space and we are representing those solutions as a binary number. And what selection is doing, it is telling you that these solutions are having good fitness, right? For example, this one, this one. So selection is nothing. Selection is doing nothing. Only selection is telling you like where you can find the good solutions. So one method which is used when you are unsure about the optimal solution is to exploit the area around good solution. So that is called as exploitation. So in exploitation, what we do, so whatever solution we have currently, we will try to identify the neighbor of those solutions, because if you have some good solutions, right? If you try to find another solution which is very near to that one, that may also be the good. So that is called as exploiting. So when you exploit the area, you may get the optimal solution. But will you be able to identify the global optimal solution only by exploitation? So that is not the case. In addition to exploitation, you have to explore the area, explore the other regions which may also produce good solutions. Because if let us suppose if I am only exploiting this region, I will be able to identify this local best solution. but definitely I am interested in this optimal solution, right? So that can be done by combining two approaches. One is called as exploitation. So first you have to identify the good solution, and you have to exploit the area around the good solution, and you have to apply some other method to search some other good areas in your search space. So that is called as exploration. So the operator which we will be using for exploitation and exploration are called as crossover and mutation. So these both operators are used for generating new solution in the search space. Okay, so I will show you how it can be done. So when you want to apply the crossover, because you want to generate the nearby solution, right? So there is a probability which is associated with crossover in nature. Actually, uh, every person is not allowed to mate, right? So that's why there is a probability of crossover. So let us suppose if crossover probability is 0.5. So how many solutions will be allowed to mate? So you have to see what was the initial population, that was 4 in previous example, and how many are allowed to mate. So 4 into 0.5 will give you 2. Only 2 solutions will be allowed to mate. So this is the method which can tell you like how many times you have to apply crossover and mutation. So when your crossover probability is 0.5 means you have to check the population size, and then on the basis of that one you have to see how many times you can apply the crossover. So here it is applied 3 number of times. And when we talk about mutation, similarly some probability is associated with the mutation. So it will give you 3.6. So around 4 times. This is the rounded value. So you have to apply 4 times mutation. So first crossover will be applied, and then mutation will be applied. There are several operators actually which are designed by different scientists, but one very popular crossover is called as one point crossover. I will show you with one example how can you apply the 1 point crossover. The purpose of crossover is to produce new solution in the neighborhood of the previously selected solutions. Let us suppose these two solutions. Okay, so first we will identify how many times we have to apply the crossover, and then from the parent pool we have to select 2 solutions randomly. So we have picked these 2 solutions, and now we want to apply the 1 point crossover operator. So what we do actually, we will see, actually you can see these are the position of the weights: first, second, third, fourth, fifth, sixth. So we will use a randomizer and pick one position. So let us suppose we use third position. So what we will do, this position we will take as a cut point, and we will cut these 2 solutions at this position. So when you cut this solution at this position, what will happen? Actually, you will break these solutions into 2 parts. This is called as first part, and this is called as second part. Similarly, this is the first part of the second solution, and this is the second part. So for creating new solution, we will be merging first part of first solution with second part of the second solution. So we will append. So this will give you 0, 0, 0, 0, 0, 0. This one and this one. So this will give you 0, 0, 1 and 0, 1, 1. So this is the method which will give you some new solution. So this is how we will be implementing 1 point crossover operator. So you will be selecting some cut point, and once the cut point is selected, so third position is selected, you will actually cut your solutions into 2 separate parts. So these 2 separate parts are there, and then you will be merging this information, then you will be able to generate these two new solutions, right? So there are two version of genetic algorithm in which you can use this crossover operator. One is called as simple genetic algorithm. So in simple genetic algorithm, you will simply replace the offspring values with their parent value. So those who have participated in producing offsprings will be rejected, means will be removed from the parent population. And these new solution will occupy as a parent, but work as a parent. And there is another genetic algorithm which is called as elitist genetic algorithm. So in that, parent and offspring, they will fight, like they will check like whose fitness is better, and only better individual will be passed as a parent population. So that matters actually. You have to see the different version of the genetic algorithm. Let us take one more example. So we have selected two solutions, and now the cut point is close to lower bit. So what will happen? You will get two new strings. So when you apply crossover and when you cut close to least significant bit, then the crossover will be used for exploitation. And when you cut close to upper bit, then the purpose of crossover operator will be for exploration. So crossover operator can be used both for exploitation and exploration. Similarly, mutation. Mutation is also used both for exploration and exploitation. It depends like what is the cut point actually. Now we see mutation operation. So after crossover, you will find some intermediate population, and then you have to apply the mutation operation. Mutation is very simple. You have to choose some solution and you have to randomly pick some uh, bit number. So let us suppose if third bit is picked, then you have to simply invert that position, invert that bit. So that is called as one bit mutation. So here that was the example. So we have already picked one solution. We have changed the bit from 0 to 1. So that is how we will be implementing mutation operation. So purpose of crossover and mutation is to produce new solutions in the search space, right? Initially in selection, we have simply created multiple copies of the good solution and rejected bad solutions. So we are not generating any new solutions during selection. And the new solutions are generated only after crossover and mutation. And the newly generated solution will be more probable, or they may qualify for being a global optimal solution. So that is how we implement this genetic algorithm. So after selection, crossover, and mutation, the newly created offsprings, newly created population is called as offspring. So what is population? Population means when you are working with some set of solution, and means in instead of working only with one solution, if you are working with so many solutions, and if you are designing some algorithm, then those algorithms are called as population based algorithm. So genetic algorithm is a population based algorithm. There are some other algorithms which you can also design. Now there are a lot of optimization algorithms. Actually, everybody is proposing its own optimization algorithm. But GA, genetic algorithm, particle swarm optimization, some algorithms are very good. And differential evolution algorithm. So even I've seen that around 50 algorithms are there. So there is no need to study all those bogus algorithms. These are good algorithms like GAPS, and D. So if you want to study about optimization, then you can see this. And actually, the important thing is, if you are working in artificial intelligence, understanding theory is not that important. If you are understanding theory, that is okay. But ultimately, you have to apply that theory in the form of computer program. So if your programming is not good, whether you are working in electronics, whether you are working in computer science or in some other area like electrical, or if you want to write, if you want to do some good things, then you have to learn programming. Programming is the topmost thing. For example, in most of the cases, people are working with the MATLAB programming techniques, but a lot of framework are already available in Python and Java. So I will suggest you to learn some programming technique, because people are going for a skill development, and a skill is what? A skill is something which you know and other person he doesn't know, right? So if you know the programming, how to write programs, how to create programs, then it will be better for you. I don't know, like, the type of the audience which we are having in this uh, short-term course. I'm thankful to the organizer that, and Miss Dr. Swati and Dr. Shilpa, that they both have invited me for this presentation. But I would suggest, if faculty members are there in this program, they should learn programming. That is really important. In fact, student also. Anyway, so we have completed one generation. So when you apply selection, crossover, and mutation one number of time, it will generate one set of solution. So only one iteration will not be enough. So you have to apply this process again and again until you get your best solution. So this is how we will be designing the genetic algorithm. So sometimes people ask, is it guaranteed to obtain optimal solution? So because you are using genetic algorithm, will it give you always optimal solution? So that is not guaranteed. But definitely you will get some solution which will be having very good fitness. Okay. Now I will show you the one very good application of binary GA. Binary GA means we want to go for optimization, and each solution will be represented by a binary number, and we will be using the operators of GA, and we will be actually generating some new solutions which will be having some which will be maximizing some criteria. So we can use binary genetic algorithm in classification problems. So classification problems are prediction related problems. So actually that is a area of machine learning. So artificial intelligence and machine learning are related, because you want to design smart machines. So classification problems, most of the times we want to classify, like, what is the correct class of this given object. So that problem is called as classification problem. Now we check how we can apply binary genetic algorithm for solving classification related problems. Okay. So first I will discuss something. So this is the problem which we want to solve using binary genetic algorithm. So why this is the classification problem? You can see there are some parameters like outlook, temperature, humidity, and wind. On the basis of that, we are deciding whether we can plate NS or not. So that is a classification related problem. So once we have created the model, we can, for a unknown input, we can identify the correct class. So that is why this problem is called as classification related problems. So how binary GA can be used in solving this problem? So because we want to solve this one. So, and we want to use binary genetic algorithm for solving this problem. We need to understand like what we have to do with the help of binary genetic algorithm. Okay. So we have seen that one database is there, some values, some input values, and the corresponding output values are there. So these are called as training instances, right? So we want to create a mathematical model. We want to create a mathematical model which can produce, which can actually, when you supply some input value, it can produce the correct solution for each and every solution, right? So we want to generate a function which can satisfy all solutions. So that is our hypothesis. So what we want to maximize actually, we want to create a function which can satisfy all input and output instances of the problem. So that is called as how we will be designing which solution is fit or unfit. So that we will design on the basis of like how many solutions it is satisfying in the available data set. So that is how we will be deciding the fitness of the solution. And what will be the solution of the problem? Solution of the problem will be a hypothesis. In machine learning, we call it as hypothesis, right? Hypothesis means a function which will show the connectivity between input and output. So in binary GA, we will be receiving some hypothesis, means solutions, and we will be checking the fitness of those solutions. And with the some initial hypothesis, we will be generating some new hypothesis because GA can automatically generate those solutions which are more fit as compared to the previous one. So once we have created some initial hypothesis, then we can apply genetic algorithm and we can generate some new hypothesis which may provide you the better solution. So that's why we are using binary GA in this one. Look, okay, so here you can see. So how will you define a hypothesis? So let us suppose if I'm writing this one, if my outlook is overcast, temperature is hot, right? And this humidity is high and wind is weak, then my answer should be yes. If I want to define a function for this input and output relationship, how can I define it? Okay. So the thing is very simple. I can simply write this hypothesis. So how many instances will be satisfied with this hypothesis? So only one instance is having this value. So only one out of 14 instances will be satisfied with this hypothesis. So this is how we can define the hypothesis. Let us suppose if I'm defining my hypothesis as, look, if I'm defining my hypothesis as if outlook is overcast and wind is weak and the play tennis is yes. So how many instances are satisfying this one? So you have to see only two parameters are given, input parameters. Outlook is overcast, this one. Wind is weak, this one. And others are not mentioned. So any value is acceptable, right? So this is acceptable. Yes, one instance is yes. Outlook is overcast. Wind is weak. Where is weak? Outlook is overcast. Wind is weak. Other values are not what we are not worried about other values. And the output is yes. So 2 out of 14 values will be the fitness. Mean this hypothesis will be satisfying two solutions out of 40. So in this way, we can generalize our hypothesis. So this is the generalized hypothesis, and this is the fitness of the generalized hypothesis. But actually, we are working with the binary genetic algorithm, right? So we will not be representing our hypothesis by these direct values. So we will be representing these hypotheses by some binary numbers, right? because we want to generate new hypothesis which may satisfy more number of solution. So look how hypothesis will be converted into binary number. Okay, so we will use three kind of representation for representing each solution in a binary number. This is outlook. So hypothesis contains these things: outlook, temperature, humidity, wind, and platelets, everything. So we write everything: outlook, temperature, humidity, wind, and platelets. Remember, and we will see how many values outlook may take. So outlook may be overcast, sunny, or rainy. So it may take three values. This is one, this is two, and this is three. So we will create three branches for this outlook. Similarly, for temperature, we will create three branches: hot, mild, and cool. And for humidity, we will create two branches because it can take only two values. For wind, we can take two, the high and weak. Okay, look, these are the input parameters, and the only output parameter which we have is platelets. So output is, or you can say output is always represented by yes or no, right? So we will be using only one bit for representing platelets. So how this kind of method, this kind of representation I will be using for representing my hypothesis. So let us suppose if my hypothesis is if outlook is overcast and temperature is mild, humidity is high, and wind is strong, then play tennis is yes. If this is my hypothesis, how I will be representing this hypothesis as a binary number? So look, I have already defined this tree structure. Look, whatever you have written over here in the different branches, you can't change it. Representation. Can't change this representation. So you will be seeing what is your outlook? It is overcast. So you see where you have used this overcast. Look, this is the first value, right? So we want to make our outlook as overcast. So we will make it 1 and all other values will be 0, 0. That's why this value will be 100 because outlook can take three values: overcast, sunny, and rainy. So overcast is 1 and sunny and rainy both values are 0, 0. So only one value is available at this time. So we are making it 1 and other values are 0. Now we will see temperature. So temperature may take three values. Temperature may be hot, mild, and cool. So we have to follow the order. What is our temperature? Temperature is mild. So only mild value will be 1 and all other value will be 0. Similarly, you can see humidity is high. So it is represented by 0, 1. Wind is 0. Wind is strong. So we are making a 0, 1. So the whole hypothesis will be represented by this one, this binary string. Let us see one more example. Here you can see this hypothesis is having more number of parameters. If outlook is overcast or sunny, so now two values are possible. It may be overcast, it may be sunny. So both values may be 1, right? So, so we make overcast as 1, sunny as 1, and other last value will be 0. And after outlook, there was, you have to follow temperature, but temperature is not given to you. And temperature can take three values. It means all three values are probable. So that's why I will be writing as 111. 111 means don't care. Similarly, uh, third value was related to humidity. So I'm not worried about the humidity. So I will be making it as 11. Wind, I will be writing 10. Play tennis, I will be writing 1. So in total, the hypothesis will be represented by this one. So how we are representing our solution in a binary number? So that is the process. You can define your own process, because ultimately, if you are working with a binary genetic algorithm, right, then you have to represent your solution as a binary number. But how you are converting your actual values into binary, it is not given to you, right? You have to decide how you will be representing your input values into the correct binary values. So that representation you will be deciding. It will not be available to you, because these programs are artificial intelligence related programs. So nothing is given to you. Everything you have to decide. Actually, because you are not knowing where will be your optimal solution, right? So you will be creating a mathematical model. And how you are creating mathematical model? You are creating mathematical model with the help of binary genetic algorithm. So you have to use binary representation. So how you will be representing your solution as a binary number? It may, sometimes it may be very good, sometimes it may not good. So it depends on your model whether you will get or accurate result or not. So this is how we will be representing our solution, our hypothesis in binary number. Similarly, there are some other hypotheses how we can represent. So if temperature is hot and play tennis is no, it means outlook is not given. So outlook will be don't care. So we will be writing 111. Temperature is hot, so we will make hot as one, other values as 00. And similarly, we can identify other values and we will represent hypothesis. So this is how we will be representing our hypothesis. After this, because in binary GA, you need two things. One, how the solution was represented in binary, and second, the corresponding fitness. Why fitness is required? Because once you know the fitness value, then you can go for the selection. And selection will select good hypothesis, reject bad hypothesis. So that you have to do again and again, iteration by iteration, until you get your solution, right? So you have to check the fitness of each binary number or binary hypothesis. So how the fitness can be calculated, I already told you. Once the hypothesis is known to you, you have to check how many solution this hypothesis is satisfying out of these 14 values. So let us erase this link. If outlook is, let us suppose, overcast, and if wind is strong, and if play tennis is yes, what will be the fitness of this hypothesis? So you have to see, first you have to see overcast, because temperature is not given, any value is acceptable. Then humidity is not given, so any value is acceptable. Don't worry about that. Wind is, you want to say wind is strong. So wind is strong means overcast, but here wind is weak. Overcast, wind is strong, and output is yes, right? So overcast, strong, yes. Then overcast is strong, yes. Overcast, but here no strong, so it will be 2 by, how many values are there? 14. If I'm saying, okay, uh, the value may be rain, hot, and no. So it means you have to check rain, then you have to check no, rain and hot. So rain and hot combination is not there. So that hypothesis will be, that there will be no hypothesis. So the value will be, the fitness value will be 0. But in most of the cases, actually, in most of the problems, we never work with this fitness 0. So we did some modifications. And there are some other algorithms where we can apply some modification over there. we are not concerned over that. So you can see like how can you modify those things. So once everything is available, this, then you can go for selection, crossover, and mutation, and you can create offspring. So you will check whether offspring, newly created offspring, is having higher fitness as compared to previous one. Yes, once your goal is satisfied, you will stop using genetic algorithm. So that is how you can apply genetic algorithm in classification related problems. There are some other classification models like there are naive-based approach, there are random forest kind of technique which is used for prediction. So other techniques are also available. So you have to see like which model may be suitable for your problem, and depending on that model, you can create solution of the problem. So this is about simple binary genetic algorithm. Sometimes actually in place of binary genetic algorithm, you can directly use real parameter version, real parameter algorithm. In real parameter algorithm, actually what we have seen, we want to optimize function over here. This was fx is equal to sin x, and we want to maximize the value of this sin x. And what was the value of this x? So it was in between 0 to 3. So what we were doing actually in binary genetic algorithm, we have to represent our solution as a binary number. But if your problem is supporting real values, so here you can see it, we want to take our number in between 0 to 3. So this problem actually is belonging to a problem where the solutions will be in continuous mode. So in this problem, actually, binary application of binary genetic algorithm is not good. So in that case, you can directly represent your solution by a real parameter value, real number, right? So newer version of genetic algorithm were designed for solving these continuous related problems. So that genetic algorithm is called as real parameter GA. So we can directly work with real values for solving problem. So that version is called as real parameter genetic algorithm. So there are separate issues with the real parameter genetic algorithm. So you can see like several other operators are there. So for example, if first solution is represented as x, this 0, second solution is represented as 1, how will you apply the crossover? So other kind of crossover was defined for this real parameter genetic algorithm. So how will you generate new value? So it is very simple. You can add and you can create half value. You can take half value of it. So that is used for exploitation. Actually, many methods were used to design a good solution. Like how can you produce good solution using crossover and mutation? So other methods were suggested for real parameter genetic algorithm. So those who want to study like how they can apply genetic algorithm and real parameter genetic algorithm, they can see uh, the literature. So that was the beautiful application of binary genetic algorithm. You can, so this is something which is related to like we are working with some optimization technique and we are using that optimization technique in solving machine learning related problems. So machine learning is hot topic these days, so you can use it. So optimization, if you are thinking that optimization is not related to machine learning, that is not the correct thing. Or if optimization problems are not belonging to different domains, that is not the correct thing, and they are directly involved in many machine learning related problems. So you can see other literature. I think from my side, uh, I have presented everything. So if you have any question, you can ask.
Good morning, sir. This is Dr. Tanuja Dope. I am very much thankful to you, sir, for nice presenting the entire contents based on AI and binary algorithm for the using genetic algorithm. There are a couple of questions, sir, from the participants. The first question is that which is the best language and tool to implement AI, machine learning, and deep learning algorithms?
Actually, people are using two languages. One is MATLAB. Actually, those who don't know about like how to write programs,
Okay.
they are using MATLAB tools directly for solving their problem. For example, if I am a chemical scientist and I want to do some, actually, you can apply artificial intelligence techniques in every area. So, but being a member from chemical engineering, I cannot write program. Let us suppose I don't know whether you have such kind of expertise or not. If you are not expert in writing programs, just go for MATLAB programming. So there are several tools which are already available on internet. Like how can you apply genetic algorithm if you know the theory of the genetic algorithm, right? And if you want to apply the genetic algorithm, but if you don't know how to write programs, then you can check the MATLAB programming language. Several tools are already available. So if you know the theory, if you know what what will be your input and what will be what thing you want to maximize, you can pass those things in your that simulated program, and it will automatically process and it will automatically produce the best solution. So that is the best way. But if you are a good programmer, you can right now people are using Python. Python is a good language actually. Python and MATLAB both are good. So if you
Okay.
want to publish papers only, and if you want to represent your uh, papers beautifully, then MATLAB may be another good
Uh,
programming language.
okay.
But
There is.
C,
Okay.
if you know C++,
Mm-hmm.
actually nobody is working on C and C++ these days.
Okay. Okay.
That
Uh,
MATLAB and Python may be good.
okay. Okay. Sir, one more question is there. So, what is the computational complexity of genetic algorithm if we compare with the deep learning algorithm? That is the second question.
Deep learning is a different thing. It has nothing to do with the genetic algorithm.
Okay. Okay.
Deep learning is something which is related to neural network.
Hmm. Hmm. Hmm.
So it has nothing to do with the neural network. So that we cannot compare actually.
Okay.
So
Okay.
those are two separate things.
Okay, sir.
If you want to check the time complexity of the genetic algorithm program,
Mm-hmm.
so actually when you are working with the randomized algorithm, what you are doing actually, because you are designing a randomized algorithm, definitely you are reducing the time complexity of deterministic algorithm. That's why you are going for the randomized programming.
Mm-hmm.
So you can check the step count and you can define the time complexity. It has nothing to do with the, actually when you are working with the artificial intelligence related problems, you are not bothered about time complexity of that kind of algorithms,
Okay. Okay.
because you
Okay.
will be interested in identifying the global best solution
Mm-hmm.
in reasonable time.
Okay.
Okay, let us suppose if you are thinking about the time and if you are not getting very good solution, randomized algorithm will run in finite time, definitely.
Okay.
Mm.
Okay. Thank you, sir. Sir, I think I have covered all the questions which are there from the participants. So, from the Department of ENTC, Rajarshi Shahu College of Engineering, I, Dr. Tanuja Dope, I am very much thankful to Dr. K. Mishra, sir, for giving us the entire details about the binary genetic algorithm classification and applications. And I'm very much thankful to sir for sparing his valuable time to deliver this expert talk. So in future also we will be very happy to look forward to you for the contribution as and when we required expertise in this area. So once again, I'm thankful to KK Mishra sir.
Thank you, madam. Thank you very much. Thank you for inviting me. And it was very good to share like things with you, and thank you for appreciating me. And I will be honored if you call me. And if anybody want, like if you have some question, if you want to ask, you can send to the organizer. I can tell you the solution. Am I audible?
Sir, you are audible, sir. No issue. You are perfectly audible to all this
Mhm.
participant.
So if you have any question, you are welcome. You can share your question with the organizer, and I will be happy to help.
Yes, sir.
With
Yes, sir. Definitely.
so, thank you for this wonderful session. Can I leave now?
Yes, sir. You can leave,
If
sir.
anybody want to ask anything, I'm here.
Mishra sir, thank you so much, sir.
Thank you, madam. Thank you very much. Okay, so I will be leaving because I have some other work. Thank you very much, madam.
Okay, sir. All participants are requested to stay in meeting. The next lecture is at 11:45 sharp. Good morning, Londe sir.
Ma'am, please make him co-host. Yeah.
Pranav sir, we will start now.
Yes, ma'am. Good morning, Narendra Londhe, sir. Shall we start?
Can you hear me?
Yes, sir. Yes, sir.
Okay, you can start, please.
Thank you, sir. A very good morning to one and all. I, Pranav Chipalkatti, on behalf of JSPM's Rajarshi Shahu College of Engineering, Department of Electronics and Telecommunication, heartily welcome you all for the second session of Day 6 of Phase 2 of AICT-sponsored 2-week faculty development program on artificial intelligence and its applications in biomedical engineering. Today we have with us an eminent speaker, Dr. Narendra Londhe, to deliver session on topic computer-aided cirrhosis disease classification and severity detection. On behalf of Department of Electronics and Telecommunication, I heartily welcome you, sir. I I feel extremely honored to introduce him today. He is currently working as an associate professor in Electrical Engineering Department, National Institute of Technology, Raipur, and has a total of 18 years of experience. He completed his PhD in Electrical Engineering from IIT Roorkee 2006 to 2011, MTech in Measurement and Instrumentation in Electrical Engineering from IIT Roorkee itself, and BE in Electrical from Sri Sant Gajanan Maharaj College of Engineering, Shegaon, Maharashtra. He has guided a total of 13 PhD scholars and 18 MTech students. He has reviewed articles from 3 international conferences and is currently reviewer for 18 refereed journals. He has to his credit 2 patents, 7 book chapters, 115 publications in international national journals and conferences, and 7 sponsored research projects worth around rupees 2.5 crores. He has conducted around 20 expert talks and lectures in various institutes. He is a senior member of IEEE and has membership of IIT Ultrasonic Society of India and 7 other technical societies. We are fortunate to have you with us today, sir. I welcome you once again and request you to start the session. Thank you, sir.
Thank you so much. Thank you for my the short introduction. With this now, I will start my presentation. Is it my screen visible?
Yes, sir. Yes, sir.
Okay. Thank you so much. Because of some technical glitches, I moved to my now compute this my mobile phone, so I'm presenting it on that. Okay, so thank you, welcome all the participants, all the dignitaries present in the presentation, faculty members of Rajarshi Shahu College of Engineering, Pune. So thank you once again, Shailaja madam, for giving this opportunity, and thank you for the invitation from the coordinators of the program, Swati Bisikar and Shilpa Sonone ma'am. So regarding my topic of today's presentation, actually it is related to one of the very what I say serious skin disease that is called psoriasis. Okay, why psoriasis, how I come to this disease. There is a little story, and I want to give you that because whenever as a researcher you find you need to find some topics which is really of useful to the society. So one of my friend is there, because this story is related to Pune only. There is one dermatologist, one psoriasis expert is there in Pune. His name is Dr. Rajendra Sonone. He is treating the patient of psoriasis since last 20 years, I guess, more than 27 years. So he He was actually, I have seen him treating the patient of psoriasis, and that time I found that he used to treat the patients using homeopathy medicine. And for treating the patients, he used to observe the patient's images, color images, photographic images. On the basis of that, he used to decide the medicine for that patient. So on every visit of the patient, he used to assess the previous images and the current images, and then he used to assess that what is the effect came from his medicine. So on the basis of that assessment of those color images, he used to decide on the medicine, which is very important. At present, if I talk about other dermatologists, they are using only the two methods, that is visual inspection. Visually, they are saying, they are looking at some part of the body of the patient, and at most they are touching the skin, and they are saying that what is the severity of the disease. So which is very subjective assessment, and that is not good enough for treating the patient. That is what we felt after discussion with the Rajendra Sonawne sir, and thereafter on in collaboration with him only, I started doing this work. Because when in my presentation I will tell you what is this disease, what is its impact on the patients. Okay, and thereafter you will be very clear about the motive of my this research work. Okay, so this is the outline of my presentation. Basically, that I will be introducing you the disease, what exactly that disease is, what is the statistics of that disease over the globe, and what is the impact of that disease on the quality of life, due to which actually I felt that I should take up this research. And that is how I designed my motivation. That is how the motivation came to me. And then thereafter I will be presenting the works that I conducted in sequence in order to reach at one very successful computer-based method for the assessment of this disease, and thereafter means how we conducted that work, what experiments we have conducted. All that will be presented in my this presentation today. Okay, and then thereafter I'll also be discussing that what is the clinical applications. So this is the beginning of the work that I am going to present. And thereafter, now this work has reached in a very advanced stage. We are using the deep learning and very higher models now. And almost two PhDs are already completed on this similar topic, same topic, and third PhD student is still working on that. Okay, so let me start with this presentation. Introduction. Now, this psoriasis is actually a chronic and autoimmune disease. Basically, it actually generates this. It actually expedites the death rate of the skin cells. Okay, and due to that, what happens? The patches, the dead cell patches actually starts to develop on the skin. Okay, so that scaly patches that scaly patches actually gives an irritation to the patient. They starts to get itching, and even the cracks on the screen in the skin, and due to that they really their life goes uneasy. Okay, so regarding this disease, if you will inquire it with the various dermatologists present over the globe, across the globe, you will come to know that there is no permanent cure for this disease, basically. But yes, it can be controlled by prolonged and the attentive treatment. Means the dermatologists need to properly assess the patients, and accordingly they have to treat the patient. So dermatologists need to have uh, the he need to focus on the history, that how I am treating the patient, what is the effect of the, because this disease is actually having the effects of many things, like what you eat, what is the season, uh, what is your lifestyle, how much is your workload. All these things are going to affect the severity of this disease. So accordingly, the dermatologist has to need to focus on many things for treating the patients, those who are suffering from this disease. So there are different types of the psoriasis. There is plaque psoriasis, then guttate, then inverse psoriasis, pustular psoriasis, erythrodermic psoriasis. There are different types of the psoriasis, but the plaque psoriasis is the most widely, or I will say that is the most occurring disease, occurring type of the psoriasis disease. Okay, so you can see here in this image, that is a plaque psoriasis image only. That is an image of the trunk. That is the image of the frontal part of your body, and where you can see that red patches is red patch is there, very huge patch is there. That patch is of the psoriasis disease, and uh, this patches comes not comes when you people are, when the patient is having means that patient has done uh, uh, serious itching, and then rubbing that lesion. So when you will if you will observe these patients, you will come to know that this patches starts with the small areas, and thereafter when that patient start itching that particular lesion, that lesion starts to grow, and then it spreads like this, something what you are seeing in your this screen. Okay, so what is the biology involved in the psoriasis? You can see in this image, actually we are in the skin, we are having this epidermis layer on the skin, on the upper side of the skin. So this in the epidermis layer, generally the whatever the skin cells are there, those skin cells are becomes dead, and they come out from this epidermis layer. But what happens in normal human beings, the death rate of these cells, skin cells, is of the range of 28 to 30 days. But the person who is suffering from the disease of psoriasis, you will come to know that that death rate of skin cells is very small. They starts to die in just 3 to 4 days. In just 3 to 4 days, that is very faster. So that's why that those dead cells deposits on the skin, and this patient starts to develop the plaques on the skins. Okay, now nobody knows about the reason of this disease. Many people has many versions of their evidences, and their versions of observations. Okay, but yes, in the one of the reason that has been found by many researchers in this area, that the reason for one of the reason is the genetic factor. They have believed in that, yes, one of the factor is the genetic factor. Now this is the statistics of the psoriasis. You all will be surprised to know that 125 million of the world population, total world population. I'm not saying these things just on my own. I have referred the literature, and that literature is cited here, literature paper number 5 and 6, that are the reports of the World Health Organizations. And from that we come to know that 125 million people across the globe is actually suffering from this disease. And if I talk about the region wise, then in Europe around 0.6 to 6.5% people are suffering from this disease. In USA, that is 3.15%. In Malaysia, that is 3%, and in India it is 1.02%. Regarding the percentage that I am showing here for India, that is 1.02%. It is very small, because I am actually observing these patients very closely because of my this research work, and I come to know that many of our Indian patients, they do not even report to the hospitals. They do not go to the hospitals for the treatment. They treat this disease at home, and they feel very embarrassed, because Indian culture is very means people are very ashamed of such kind of diseases. They do not want to disclose it to the general people. They hide it. And as this disease is this disease does not have any means like if you people are having some cancer or something, then you will be having other symptoms, those who are very serious and that needs immediate attention. But this disease is just this disease is not like that. It actually only destroys your skin. It only gives you the discomfort, and that discomfort is very serious, and it also gives cracks in your skin. Your skin starts to bleed many times. It also develops arthritis, means almost 30% of the people, those who are suffering from this disease, they develop arthritis. So this arthritis, you all know that it is very painful sometimes in the seasons when now this present season where now the winter has started. In this kind of season, this arthritis creates a lot of problem. So if but and very important thing is that whatever this psoriasis spread is there, if you will see the age group, you will surprised to know that majorly the youngsters is suffering from this disease. In the age of 20 to 30 years of people are majorly suffering from this disease, which it means this disease is actually spoiling our young generation, right? And and in that also, during the research they have found that heritability is almost 60 to 90% they have found, and that's why I told you that yes, they have mentioned as genetic factor one of the reason due to that. And there is other observations also, that if one of the parents of of any child is having the psoriasis, then there is a 16% chance that that child also develops that psoriasis. Even if both the parents are having the psoriasis, then there are 50% chance that the child will develop that disease. So that is very that is very what I will say, very concerned. Means this is not very common with other diseases. It is not like that some if into their children. Okay. These patients really feel discomfort, and they really do not, they want to hide the disease. And because of their hiding the disease and staying away from the social gatherings and everything, they do not actually involve with their family members, they do not involve with their relatives, friends, and that creates, and they do not even go for their work, and due to that they starts to develop stress, and that stress level goes so high that you will surprised to know that 30% of such patients, they contemplate suicide. Now here, this is the matter of concern. This is the matter of concern, means 30% of all the patients are committing the suicides in this case. The death is not because of the disease here, but the death is only because of the discomfort of this disease, because of the discomfort of this disease to the patients. They really are not able to bear that stress, they really are not able to bear that itching and that discomfort on the skin. And this disease is not like that it will only occur on one part of your body, it can occur on any part of your body. So that is really difficult to means take care at home. And that is why this death rate is very high. 30% is very high number of deaths in this particular disease. So it also affects the quality of life. People, as I told you, that they really feel discomforting social discomfort in having the social appearances. They also develop the stress, anguish, embarrassment, and that is because of that the disease also even becomes worse. So that actually it does not reduce the impact of the disease, but it increases the impact of the disease. Okay, so approximately 60% of these patients miss an average 26 days of work every year. Means they do not go to their work. There is to some time, because as I told you, this disease has having the effect, seasonal effect, or seasonal effect. At some time in the year, that disease becomes very aggravated. So during that time, it is really difficult for the patients to go for the work, and that is why they lose their employment, they lose their livelihood. So this is something which actually this is something which actually add up into their problems. Okay, it means you just look at what I said, that is creating social embarrassment, that is creating, obviously the discomfort is already there, then there is loss of employment, and due to that the stress pile up. heavy stress pile up on the patients, and that is how they are contemplating suicides. And if you will now just look at the death rates that is happening into the psoriasis, you will come to know that the death rate is very similar, and that is at par with the deaths in the cases of heart disease and depression and diabetes. So it means that even though the deaths are not only because of the disease, but even though it is because of embarrassment and discomfort, whatever it is, but the deaths are very equivalent to the death rate in the other serious diseases like heart disease and diabetes. But in cases of heart disease and diabetes and depressions and everything, you have many assistive technologies available that doctors used to assess the patients in a very serious way. They used to do the scans, MRI, CT, ultrasound, everything. They even operate the patients. They can. But if you will see in the case of psoriasis, these things are not there. Even what you will means it is you I wish to tell you that even the psoriasis patients are very sensitive to develop another diseases as well, like metabolic syndrome, type 2 diabetes, and cardiovascular disease. So if somebody is having this sort of disease, so they are also very sensitive to the sensitive to the diseases, and there is very much chance that they will develop such diseases like diabetes and cardiovascular diseases. Okay, so that is why we come to know that this psoriasis disease is a very major concern for the healthcare organizations and the society. So it's not it is though this disease is very neglected type of disease, but its impact on the society is very equivalent to what other diseases are having the impact. Okay, so what is the present status of treatment of the disease, this disease? So as I told you that it is having only the subjective assessment. The dermatologists do the visual inspection and the sense of touch. They visually actually look at the patient, and they look at some part of the patient's body, just to observe that yes, whether whether that patient is having the psoriasis or not. And once it is having the psoriasis, they do the sense of touch. At most they do the they touch the skin, that infected skin, and from that they used to find out what is the severity of that disease. Okay, but uh, as this kind of inspection is having this kind of inspection is it suffer from many drawbacks. And one of the drawback is that inter-observer variability. It means that the two dermatologists for the same patient can have a different opinion as per the subjective assessment. And it also can suffer from the problem of intra-observer variability. It means that the same dermatologist can have the different opinions on two occasions for the same patient. So that it means that this subjective assessment is not successful, and it is having limitations. So at this, they are having the limitations. At the same time, this sort of things, if now the dermatologist wishes to see the spread of the psoriasis on every part of the body, then that doctor has to spend a lot of time to look at each and every part of the body, see the spread of that disease, and to assess that disease, then touch those infected skins, and then try to understand what is the severity of that disease. So it is a very tedious and time consuming task, and generally the dermatologists do not spend time over that. Okay, and that is why the subject assessment goes inaccurate, and it is totally unreliable process, right? So therefore we thought that there should be some means we come to know that yes, we need to have that these dermatologists need to have some supporting diagnostic system, because as I told according to the reports of the World Health Organizations, countries like India is having the patient doctor ratio almost equals to 2000:1, means one doctor needs to attend 2000 patients. In such kind of scenario, it is really difficult for the doctor to spend so much time in assessing the patient. Okay, so that is why in cases of heart disease and something other diseases, there are different facilities are there, that they are having the diagnostic tools, like diagnostic imaging is there, then diagnostic signals they like ECG, EEG, EMG. They also have the physio what I say then pathological testing is there, like you people do the blood testing, and then you to do the skin, even skin cells are being also tested. So that sort of technical assistance is all there. But in this case, but in this disease, that assistance is not there at all. That is what is the problem. Okay. So it would be beneficial for if we design any diagnostic system which can support the dermatologist, it will help them to assess the severity of the disease, and in also understand the evaluation of their treatment. Okay, that whatever the treatment they are doing, whether that treatment is going in a correct way or not, whether it is really improving the status of the patient or not, that also they need to record, they need to understand that. Okay, see, if one patient is coming in 1 month, and in it the same patient on his another visit coming on the second month, then the doctor needs to see that in the 1 month, in the total period of 1 month, what was the effect of its treatment. Okay, and how that disease has been is actually developed, or during that one month. So that everything needs to be understood by the doctor, and then only he can provide the effective treatment. Okay, so that is why, because of this, all understanding all these limitations of the subjective assessment, there is we understood that we should provide them, the dermatologist, the computer-aided diagnosis system. Okay, which we can provide them then some sort of automated system where total assessment of the disease spread can be easily documented on one system, and every time the doctors visits the meets the patient, he can see that assessment, and accordingly he can treat the patient. So that is why we have thought to decide the we have thought to design the CADEX system. Now, what is CADEX system? Actually, CADEX system gives you the quantitative evaluation. Means it's not like that. Just like in subjective assessment, the doctors used to see one part of the skin, or one or two lesions of the skin. But in it is not, the dermatologists do not look at the all the parts of the body, so it is not quantitative basically. But yes, if you design the CADEX system, it can be quantitative in nature. Okay, and that CADEX system also gives you the facility of reproducibility. Means if some assessment is being done at one time, and if you do it at the another time, the same things will be reproduced. And this sort of CADEX systems are automatic in nature. Means doctor need not to do anything. He just have to like in CT and MRI images, they just take the imaging, they do the imaging, and thereafter all that images being automatically assessed, and on the basis of that, one diagnosis report is only given to the doctor. Okay, we do not give, if he wishes, then he wish to see the images and everything. But otherwise, if you will see, they just provide the doctor one assessment report, and on the basis of that assessment report, doctor immediately gives the treatment. Okay, and likewise, we can also provide such sort of CADEX system to the patients of psoriasis. And in that CADEX system, there is also a possibility of generalization, because generalize in the sense that yes, some sort of because the whatever the people, those who are having this disease, psoriasis disease, they can have white skin, then there is wetty skin, then there is black skin. So looking the severity or assessing the disease on different type of the skins is really difficult. See, if I'm seeing one, say that I'm seeing one lesion on the skin of white skin, and I'm saying that it is severe. Okay, if I see the similar lesion on the black skin, I may get confused whether it is severe or not. So that sort of problem may be there. So we can design a CADEX system where on the basis of the machine learning and deep learning algorithms, that system can be trained for different colors of the skins. So our system can become more generalized. Means it will be able to discriminate between the different skins and the lesions on that skins, right? So that is why, on the basis of that, all these hypotheses and theories, we decided to design a CADEX system for the diagnosis of this disease. Okay, now why when we decided designing this CADEX system, then we thought that what should be the standard for designing this CADEX system? There must be some standard. means there must be some standard on the basis of which the dermatologist must be assessing the patients. So yes, there is one standard that is called psoriasis area and severity index, which is already available in the literature of the psoriasis disease, in the handbook of the psoriasis disease. Okay, what this psoriasis area and severity index, it is actually a score which actually gives the clinicians the idea about the spread of the disease and the severity of the disease, basically. So in this particular in this particular index, what happens, the affected skin area is actually learned from the three symptoms, that is erythema, that is redness of the skin, matlab, whatever the infected skin is, that how much is the what is the color of that skin, means it will be always redness, but that what level of redness is there, what level of scaliness is there, what level of thickness is there, thickness in the sense the elevation, because when that dead cells will deposit on the skin, then it will be it will be rising above the skin. So what is the elevation from the skin? That is nothing but the thickness. So all these three parameters, all these three symptoms gives you the idea. And the fourth symptom, or fourth, it's not symptom, it is a one parameter, that is area, that how much part of your body is actually infected by this disease. So area, redness, scaliness, and thickness. If you have all these three parameters known to you, then on the basis of that, you people can find out this psoriasis area and severity index, and on that can help you to treat the patient in a better way. So basically this index is actually has been derived based on the psoriasis area occurrence in different parts of the body, like head, upper extremities, lower extremities, and the trunk. So in the upper extremities, in the sense your hands, lower extremities in the sense your legs, and the trunk means your abdominal region and the backside. Okay, and the head means, as I told you, that it develops in all parts of the body. So in head also, like in your skull, under your hairs, also this disease can develop. So that is also one of the location. So now this is the formula of the that index, that is you can see here, that is PASI, that is psoriasis area and severity index, PASI, is equal to 0.1 in bracket RH plus SH plus TH plus AH. Sorry, bracket complete into AH. Now, what is this 0.1? 0.1 actually, you can see here the subscript has been used at the H, small h. H indicates the head. So they have given the weightage to the head as 0.1. Okay, and this capital R indicates the redness, the capital S indicates the scaliness, this capital T indicates the thickness, and then all these three symptoms summation is being multiplied by the area, that is capital A. So that is one part of your body, that is head. And similarly, then there is a U. You can see the subscript U has been used, and that is upper extremity, that is your hands. And for the hands, the weightage of 0.2 has been given. Likewise, for the trunk, the weightage has been given of 0.3, and then your lower extremities, that is your legs, the weightage has been given of 0.4. So that is how this disease, you can see these are the sample images of the lower and your upper extremities for the hands. And we have also shown here the patches here, that skin patches that has been shown here. So you can see this is how the hands are going to get infected when in the patients of the psoriasis, right? So these are some trunk images. You people can see here that the trunk is infected, abdominal part and the trunk part is actually infected by the psoriasis. So these are the trunk images, and then these are the lower extremities images. So these are some sample images that I wanted to show you. So you people can understand that this is something very, this is not that simple. This is very serious disease. You can see the spread. Total legs are going to get occupied if that disease becomes severe. Okay, in your total trunk, means total your upper extremities, your hands, they can totally occupied by that disease. So in that PASI area, whenever you give that redness score, RH, AH, and TH, and your SH, so that SH, RH, and all that things, that is nothing but the score. And how to decide that score? So when say that you are having the patch of light red, then you will say that it is a mild. the severity is mild, and you will give the score of RH is equal to 1. Likewise, if the patch is having the color between light red and dark red, then it will be a moderate. So you will be giving the score of 2. So in this, you can see here the score has been given here. That is you people can see dark red, then very dark red, and having the score of 4, 3. And you can see at the same time in the similar mild, moderate, and severe and very severe categories, you can also assess the scaliness of the lesions, and that what is that partial coverage of the lesion with the fine scales, then major coverage with the rough and thick scales. So due to that also, that also been is having the scores of 1, 2, 3, 4, mild, moderate, severe, and very severe. Likewise, for the thickness also, there is a slight elevation, moderate elevation, deep elevation, very deep elevation. So if that elevation is as per the elevation, the score is again being categorized into 4 categories, that is mild, moderate, severe, very severe, having the scores of 1, 2, 3, 4. And then there is a area score is separately is there, because area is something where actually that where you are able to understand that how much is the coverage of the disease, how much part of the body is being covered by that disease. So if the 1 to 10% of your body is covered by the disease, you will be having the score of 1. If your body is having the coverage of 50 to 70%, you will be having the score of 4. And if the coverage is 90 to 100%, you will be having the highest score of 6. So that is what is the this disease, that is that is what is the scores of the different symptoms of the disease. Okay, redness, scaliness, thickness, and area. Okay, so these are some samples where I am showing according to the severity that how the redness will look like. You can see in the first line of images, that is a mild, then moderate red, and mild red, then moderate red, then severe red, and then very severe red. Okay, so that is as per the redness. Then second line of the images, you can see that is according to scaliness. Then third line of images is showing you the scores or severity of the disease based on the thickness. Okay, so this is about the standard index, that is PASI. So what I mean to say here, that yes, there is a standard index, but the dermatologists do not use it. The dermatologists do not use it because they really are not able to assess the patient in a complete way. They are not assessing the patient's every part of the body where that disease has been spread. Okay, so that is why they are not using this index. They are not doing any recording of this index. But yes, that index is there in the literature. So what we thought, I have decided the motive of that work, that someday I will design a system. I will keep developing this system, and I will someday will design such a system that before patient going to the doctor, there will be one scanning section will be there where on the basis of the color photographic images, we will be able to find out each score, like area score, thickness score, redness score, scaliness score, and ultimately we will find the PASI score, and that report will be given to the dermatologist so that they can save their time to look at the patient, okay, to assess the patient, and they will directly can give the needful treatment to the patient. And they can also be able to track that how that disease is actually developing, or whether that disease is reducing, what is the effect of the different environmental conditions on that disease. Or it's not only environmental, other, like if your work life is very fast, then that will having the different effect on the disease. So all that things doctors can really assess. They can really track if we develop that sort of system. Okay, so that is what is the motive of my work, and that motivation has been actually we derived because because of the seriousness of this disease. Because as I told you, 125 million is a big number, which is uh, which is uh, which is 125 million people suffering from that disease is very high, and out of that 30% are contemplating suicide. So that is something very serious. The death rate is very high, though it is not because of the exact directly from the disease, but indirectly it is actually creating the deaths. So that is why the objective assessments means computer based or automated systems is really required, so that the various limitations in the subjective assessment can also be eliminated. Okay, so that is why we have decided to design this CADEX system, and we really thought we really think that this CADEX system will have many advantages. And as I told you, that tracking the disease, and then if a assessment of the different work conditions, atmosphere, everything, that all can be done if you are having this CADEX system with you. Okay, so this there are some CADEX system which has been designed for another skin disease like melanoma, and they are having very encouraging results. So that was also another motivation for me, that yes, it is already there for some skin diseases. So why can't we develop it? So that is how we have motivated for pursuing this work. And I'm now pursuing this work from since last 6 years almost. So in the year of 2015's beginning, that I had started this 15 and 16, 17, 18, 19, 20, total 6 years completed. Okay, so yes, for that, for designing any CADEX system, and this is actually basically we wanted to develop on the basis of images. So where that data will come from? Yes, that data actually, as I told you in the beginning itself, that I had some fruitful discussion with the Dr. R.S. Sonavne, who is having the one research center in the Pune itself, in your city only, and he's treating the patient from last 27 years. So uh, uh, his immense experience and his unique style of treating the patient has only given us the motivation. And with his guidance and with his support only, because all that data, he is having the one style, that he used to capture the images of the patients every time, as I told you, and he used to see that images every time whenever the patient visits him. Okay, so in the present visit, he used to see the images from the last visits, and he used to assess that what is the effect of his medicine, what is the how the disease is actually developing, and accordingly then he decides the medication for the present visit. So that is how that was his style. So I thought, why not to he is doing it in again an subjective way. He is actually subjectively seeing that images. There is no actually there is no objective measurement from that images. So we together have decided that we will develop this objective method for assessing those patients. Okay, so this data evaluation in my first experiment, when I started doing work on this particular topic. So for that first in my first experiment, I decided that when I will develop for developing this CADEX system, I first need to see that my CADEX system should be able to understand that yes, this is a psoriasis image, and this is not the psoriasis image. Okay, so we started our first experiment with that concept. So for that, with the help of the Dr. Sonone, we have created and whatever the images image database he has provided to us. And yes, we have as per the requirement for the developing the CADEX system, he has helped us to acquire those images in a proper procedure. Okay, so he has accepted our that request. He adopted our procedure, and then accordingly he has captured the images, and then he provided those image database to us. And from that images, what we did for doing our this first experiment to understand whether the disease is psoriasis or not, we have created a database of 540 images where we have taken 270 normal skin images and 270 psoriasis images. Okay, and for that, for all these 540 images, the Dr. Sonone sir has given the rating. Yes, this is psoriasis, this is not the psoriasis, this is psoriasis, this is not the psoriasis. So that the ground truth actually we had generated for the CADEX system with the help of Dr. Sonone. So these are some samples of those database. You can see here, these are the samples of normal skin images, and in the downside, you can see the samples of the abnormal skin images. Abnormal in the sense psoriasis skin images. Okay, and this is our system that we had designed. That we had two parts on our system. That is, one is offline, that is a training phase, and then there is a testing phase. So in the training phase, what we did that we have taken all these sample images and we extracted the features from those images, and from that features. So now whatever the features that we are extracting, those all features may not be useful. They may be redundant. They may be having less information with them. So we have also developed our own feature selection technology based on PCA, principal component analysis. Okay, and with the help of that feature selection method, we have selected only the discriminant features, those who are having the higher discrimination power. Only those features we had selected, and that features has been given to the classifier, and those classifier, you can see here that classification system. Here this classification system is there, and those classification systems machine parameters we just use that is as it is in our testing phase, where you can see in the testing phase also the images are coming, then feature extraction is there, then again feature selection is there, and we are doing the online classification of the test images in the two categories, that is either it is a psoriasis lesion or it is a healthy lesion, healthy skin. Okay, so just we have not stopped our work doing this only two things. We also have done the validation of our this work, and we also have find out the reliability index of our this proposed system. Because see, as there may be some many researchers in this presentation today attending this program of my I wish to tell them that it is not easy. Design any classification system. Your classification system can give you the random results at random attempts. Okay, so that sort of thing should not be there. If it is there, then your system is not correct. So we need to work also on that. Yes, your system must remain reliable and it should give the best. Means there should be a property of reproducibility, that whatever the results that you are getting at one instant, the similar results you should get in the another instant with for the same data and for the same conditions. Okay, so that is what is the reliability is all about. So we have done the feature extraction initially. When we were doing this work, we were not aware that what features we should take. But yes, from the index, psoriasis area and severity index, as I told you, there are three symptoms like scaliness, thickness, and the redness. So from that three symptoms, we understood that there are possible only two features. One is the redness is related to the color, while thickness and the scaliness, it can be related to the texture. It is related to the texture. So that is why what we did, we have taken two types of the features, that is texture and color features, from the literature. So now while calculating these features, texture and color features, so we were not aware that which type of the color feature will work for our classification system, which will give you give us the best results. So what we did, we initially had taken all types of gray texture features, all the texture features available in the literature, and all the 14 color spaces we have used. So initially for the texture features, we have taken this all nine type of color features. You just look at this. 9 type of texture features we have taken: GLCM, GLRLM, then intensity histogram features, invariant moment features, GLDS features, and all these texture features we had taken. And out of that, we have created 687 texture features from one single sample image. You just imagine 687 features from one single image. And thereafter we have taken the color features. So color features, in generally when we are talking about color features, say that you people want to take the color features from the RGB, so you will be taking a red color, green color feature, and then blue color feature. Likewise, so what we have done, Why only we need to take it in the RGB domain? We have converted our image into another color spaces. Total 14 color spaces are there in the for the digital color images. So we converted our images into these 14 color spaces, and from that we have created our own color features. Total amount of that color feature is 172 color features, because 13 color spaces are having 3 color channels and 4 statistics values, and one color space, that is CMYK, is having 4 color channels and 4 statistics values. So total 172 color features we have generated from one single image. So aggregating this both texture and color features, total 859 features we have extracted from the one single image. So that 859 features are very huge, right? And it is not necessary that all those features are related to me or they are very useful to me. So that is why we need to go for feature selection and handling so many features. And as I told you, I have taken 540 images and 859 features for 540 images. You just imagine, so huge data. So using such a huge data makes the things computationally costlier, okay, for the classification system. So that's why it is really a good idea to actually select the discriminant features. Don't use all the features, use some selected features. Do the some feature selection. So what we did, we have taken the principal component analysis initially, that you already know about this principal component analysis. Many of you must be aware of it. What happens in this? For all the extracted features, it generates one principal component, right? It generates principal components. So but here, when that principal component generates from PCA, we really not able to understand that how much is the contribution of each feature in that principal component. Okay, and that is really difficult to understand. That yes, still I don't know what are my discriminant features. I am just only stepping down, or I am just downsampling my data from 859 to one single feature, right? But that is not good enough. I want to also understand that what features are useful, what features are having the discrimination power. That is really not able to understand from the conventional PCA. That is why what we did in PCA, we did some modification and we made it as a PCA with polling contribution. Polling contribution in the sense that if you know about the PCA, what happens in that, actually we compute the covariance matrix of the data set, and from that eigenvectors and eigenvalues get generated of that covariance matrix. Okay, and they contribute towards the formation of the principal component. But in this, what we did, we actually sorted the eigenvalues in the descending order, and accordingly we have arranged the eigenvectors. Okay, and in that eigenvectors, what we did, we just find out with the help of one cutoff. Generally in the PCA, there is one default value of this cutoff, that you make it as a 0.99. Means what will happen, all the features those who are contributing to the principal components are getting actually selected. Okay, so what we did, we have decided that cutoff from 0.9 to 0.99, and then we can compute the contribution of each feature. We contributed the contribution of each feature by using this formula that you can see on my screen, step number 5, that is Ci is equal to summation k is equal to 1 to Vki, where Vki indicates it indicates the ith entry in your this what I say, eigenvectors, right? So and we then sorted out our these contribution factors, and on the basis of that sorted contribution, then we come to know that yes, this particular feature is having this much contribution, this particular feature is having this much contribution in the principal component. Okay, so that is how we have keep track on the contribution of each feature in the PCA. That is why we say that yes, this is our new method of polling contribution, where we are actually keeping the track of the contribution of each feature in the principal component. Okay, and then we have used the classification method, that is SPM, that is very known to you, that is very popular and very known to you, that it is having a hyperplane between the two set of samples, and that hyperplane we increase the width of that hyperplane in such a way that the two categories, your data is being categorized into two classes. Basically, it is a two-class system. It is a two-class classifier. Okay, so at the same time, here also we have used validation, that is cross validation, tenfold cross validation. Now, what is tenfold? What is cross validation and why it is useful? I know many. It may be possible that many of you must be aware of this. That is cross validation. But I want to still mention you here that when you give your data to the system, okay, you give that data in as one sequence. Say that you people are giving the 10 images. You are giving first image, second image, third image, fourth image, fifth image for the training. Okay. But if you change the sequence of that images, you will come to know that your learning of the system becomes different, right? This happens, and that is why you people get random results for the date for your if you do not follow this cross validation. So that is why it is really a good practice to you do the cross validation. In cross validation, generally say it is tenfold. So in the tenfold, what happens that if we are having the 100 images, what we will do, we will make the 10 groups of that 100 images. First 10 images will come into the group 1, group 2, group 3, group 4. Likewise, that total 100 images will come. And while doing the training, then we will be giving the group 1, group 2, group 2 up to group 8, group 10 in the first training cycle. In the second training cycle, what we'll do, we'll give the groups in a different way. We'll give the first group 2, group 3, group 4, and up to group 10, and then after we'll give the group 1. So likewise, you will move the cycle. You will move the cycle, and it means that if I do the tenfold cross validation, I'll be running my training cycle for 100 times. 100 times. But if you're not doing this, you will be randomly doing it only one time. You will be doing the training cycle only one time, and that because of that, your system will not be able to train properly, and that learning will not be good enough, and you will be having some random results every time. But if you do this the training by using the tenfold cross validation, your training will be very deep, and that will be very correct. Okay, your system will be more trained, and the randomness will be reduced. Okay, unpredictability, the unreliability of your system will reduce. Your system will become more reliable. Okay, more predictable. Okay, so that is what exactly the cross validation is all about. And then we have conducted our experiments. Then for developing any CADX system, it is not an easy task. You have to design many experiments. So we also have designed while conducting this experiment, we decided that we will conduct the experiment in two way. We also will see the effect of the data on data size on the experiment. So what we did, we conducted the experiment with a fixed data set of 540 images, and then we also have changed the data size, like only 50 images we have given, then 100 images, then we also conducted for 150 images. And then we also have seen that what is the effect of the data size on the performance of the system. Okay, so for the fixed data size of 540 images at different cutoffs of the PCA from 0.9 to 0.99, we have received yes, you can see this is the cutoffs of the PCA, and this are the performance parameters of the classifier, that is sensitivity, specificity, accuracy, and area under curve. So we did it at different cutoffs of the PCA, and we found that at the PCA cutoff of 0.93 and with the fixed data size, we are having then sensitivity of 100%, 99.5% specificity, 99.77% accuracy, and area under curve is 1.0. That is almost means it is the classification is very good. It is very excellent. Okay, so with that we did this experiment. Thereafter, what we did, we have changed the data size. As I told you that we have created the data size of 50, 100, and 150, likewise up to 540 images. And thereafter, at different cutoffs of the PCA, we have calculated the accuracy of the accuracy of our the SCADA system at different data sizes. You can see it on the upper side, that is 50, 100, 150 up to 540. And this is the accuracy variation that we are finding. Now, The researchers, those who are sitting in this presentation, I just want to show you here that, see, the accuracy is not same. It is changing. It is very different. Okay, at different cutoff, it is with the different data size, the thing is changing. Okay, so what it is indicating, we plotted it at all the different cutoffs. हमने average accuracy लिया है और नीचे data size के साथ उसको हमने plot किया. By looking at this plot, you people can see that initially this plot is showing that there is a change in accuracy. There is some variation in the accuracy when I'm changing from 50 images to 100 images, 150 images. That accuracy is actually having the deviations. But after 350, the accuracy is almost stable. So what it is indicating that this system is will starts to give the best performance or best results when I'm using the data size of 350 and more. Okay, so that is the effect of the changing data size. And secondly, as I told you, that we also have calculated the reliability. For reliability, what we did at different cutoffs, we are having different accuracies available there. So we thought that why not to find out the reliability. That reliability formula then we have derived, which is nothing but 1 minus delta n divided by mu n. So this del n, what it is, del n is nothing but the standard deviation, and mu n is nothing but the mean of the accuracies. And with that, at different data sizes, we calculated this reliability index, and we come to know that our reliability index is coming as 92.75%, which is very good. It means that 92% your system is reliable. Okay, so that is what exactly we did. Then we also have found the feature retaining power. Feature retaining power, what is exactly is this? As I told you that we have done the work of polling PCA with the polling contribution for the feature selection. So in that, what we have observed that which features are are more discriminant. Okay, so at different cutoff, say at cutoff 0.9, at cutoff 0.91, which features are common, and that is what exactly we did with the feature retention power. We calculate the feature retention power. So what is that feature retention power? I will brief you from this table itself. You can see here in the first cutoff, the features are 33, and in the second cutoff, the features are 36, and this number of features are two cutoffs, 0.9 and 0.91. 30 features are common. In this 33 and 36 features, 30 features are common. And if I take the ratio of this, that feature retention, that how much features are being retained, so that my feature retention power is coming as 90.91. At the second cutoff, like 0.90, 0.91 and 0.92, ये दो कट ऑफ के बीच में मैंने फिर से फीचर रिटेंशन फाइंड आउट किया. 0.91 में फीचर्स आ रहे थे 36, 0.92 में मेरे फीचर्स आ रहे 39, and in that 31 features are common. So my feature retention power is becoming 86.11%. So likewise, I have calculated the feature retention for all my 10 cutoffs, and I've come to know that 85.51% of features are common, are retained. Okay, it means that this is giving me an understanding about my features. Okay, that whatever 859 features that I have selected, out of that 859 features, 85.51% features are useful to me. They are having the discrimination power. They are having the discrimination power of understanding that whether it is psoriasis or not. Okay, so that is what exactly as we had done in that particular part of our work. Then, so in the first experiment, we were just doing it that to understand that whether the from the skin images, whether the person is having the psoriasis or not. Okay, so but yes, if the person is having the psoriasis, then how much severe that disease is, that also we need to find out. So for that, what we did, so severity of the psoriasis can be done if you, as I told you, in the PASI score, that you people are able to understand the severity of the disease by learning the score of those symptoms. कि कितना रेड है, कितना स्केल्स बढ़ गया है, कितना आपका थिकनेस है, उससे from those parameters you are able to say that yes, it is mild, it is moderate, it is severe, and it is very severe. Okay, so what we thought that let's have one hypothesis that कि color strength, मतलब redness जो है जिसमें color है, that color is giving you the severity, understanding of the severity. And at the same time, for the scaliness and the thickness, texture features is going to give you the severity. Okay. So on the basis of these two hypotheses, we also have derived third hypothesis that it may be possible that texture and color features, means combination of the three symptoms like redness, scaliness, and the thickness. Combination of these three symptoms will also give us the idea of the severity. So that was the third hypothesis. And fourth hypothesis, what we have thought, that the reliability of the CADEX system is adequate, then the CADEX system is able to correctly classify the lesion severity. So on the basis of this four hypothesis, what we did, we have designed the severity assessment system. Means earlier we are just classifying the disease, now we are actually finding the severity of the disease. That if some person is having the, if one skin lesion is having the psoriasis, then what level of psoriasis that is. Okay, so for that we have taken the data again of 848 images, and from the 65 patients, means 65 different patients, we have created this data of 848 images, where healthy image samples are 383, mild 47, moderate 245, severe 145, and very severe 28. Okay, so likewise this 848 images we selected, these are some sample images that has been shown here of different severity classes, and healthy, mild, moderate, severe, and very severe. And this is the system that we had designed again. So what system that we have designed in our earlier work, the same system we have modified further. And here you will just see one change here, that whatever the features extraction is being done, that extraction we have separated out for color feature and the texture features, because based on our hypothesis number 1 and hypothesis number 2. And then there is a in the online system where we are testing the images. In that, whatever the online classification we are doing, it is not bilinear classification now, but it is a multi-class classification where 5 classes are being used. That is healthy, mild, moderate, severe, and very severe. Okay, so that is what exactly we have done. So for that, what we did, we have created 3 feature sets. First feature set we have created as only of color features. Then we have taken the second feature set only of texture features. Then we have taken the combination of both color and texture features, just like we have taken in the earlier experiment, that is FC3. Okay, and we have again used the same classifier, that is SVM, for our this experimentation. And for that, from that, and we did the five class classification here. And all that things we have used 10-fold cross validation and everything, PCA port based polling contribution and all. And in that, we found that whatever the accuracy we are getting for all the 5 class classification, we have taken the average of those accuracies. And for feature combination 1, only for color features, only for texture features, and combination of color and texture features, we have received an accuracy here, which has been shown in this bar chart. You can see here the accuracy is close to 98%. So by doing this experiment, or by observing this bar chart, we come to know that we understood from this that yes, every feature is having the discrimination power. Only single color feature also you are getting the good. You are able to do the diagnosis. Only with the texture features you are able to do the diagnosis. And with the combination of both color and texture features, you are still going to do the diagnosis, and having the accuracies very close to each other. Okay, so this validates our hypothesis of 1, 2, 3. So it means that, as I told you, that hypothesis that color features will be color is responsible for the severity, or texture is responsible for the severity, and the combination of both is responsible for the severity. Yes, so that both the 3 hypotheses we validated in this experiment. So thereafter, for the hypothesis number 4, where actually the reliability we need to assess, if the system is reliable, then we can say that the classification of the system is very correct. Okay, so for that we have again done the experiment with the different data size. So here this time what we did, that data size we have changed as per the percentage: 20%, 40%, 60%, 80%, and 100%. And for that, our system accuracy we have calculated, and you can see in this table FC1 is having the accuracy of 96.06%. With FC2, we are getting the accuracy of 91.7%. With FC3, we are getting the accuracy of 93.72%. So that is the thing. And here also you can see that arrow is showing here in this plot. That arrow is saying that at the 60% of the data size, after the 60% of the data size, the accuracies are getting stable. So it means that you should actually train your system with, or you should actually operate your this system with the 60% of the data. Means 848 ka 60%. Okay, so that is close to 500 images. So it means you should give at least, likewise in the earlier experiment also I said that 350 images you should give, then you will be having the best performance from your system. Here also it is coming that 500 images must be used, so that you will be having the best performance from your system with all these three types of the features. So that has been assessed here. At the same time, we have calculated the reliability index just like we did in our earlier experiment. And for three types of these features, FC1, FC2, and FC3, the reliability values is coming 98.51%, 96.73%, and 98.05%. Okay, so this is indicating that yes, system is way far reliable now. So why it has happened in this case that the reliability is higher compared to in the earlier case? In the earlier case, we were doing only the first two class classification, and whatever the images we have chosen there, we were not there was only the two because of because of the two classes, the discrimination was very easy there. And thereafter in the another class, means where the psoriasis images were in that class, the severity is not uniform, means severe, moderate, uski kitni images hai, that is not actually fixed. Okay, but in this case we have fixed that. We have taken moderate का इतना, mild का इतना, healthy का इतना, इसका severe का इतना, very severe का इतना. And we had also used here 5-class classification, and for every class we have calculated the accuracy, reliability, and for all the classes at different cutoffs we have then taken the average of that. So that values are coming here. So that is what if you will see the reliability compared to the earlier system, the reliability here even improved. It was earlier 85.51% when we are doing the work of 2-class classification, but in case of 5-class classification, the reliability is now increased to 98%, 96 to 98%. Okay, so that is what exactly we did in our second experiment. So I think it is already 1 p.m. ma'am. Hello.
Yes, sir. Yes, sir.
How much time left? Shall I continue?
Yes, sir. No issue.
If with the permission of the team, I wish to continue only for 10 to 15 minutes further, because this third part will be more interesting. And the people, the participants present here, they will be able to understand that when they start to conduct any research, how deep we should go. Means saying that I'm designing cardiac system is not that good enough. You have to do the experiments, all the possible experiments. You have to see your work. Means जितना भी पॉसिबल इश्यूज हैं, उन सभी इश्यूज के लिए आपको एक्सपेरिमेंट्स परफॉर्म करने चाहिए, एंड ऑल दैट इश्यूज मस्ट बी रिजॉल्व, so that you can say that yes, now this cardiac system is ready, I can put this cardiac system into the hardware, and now that hardware can be used for the diagnosis. It can be it is ready for the clinical adaptation. So for clinical adaptation, your cardiac system must be tested for all the things, and that is what exactly actually my team is doing since last 6 years. Okay, so this is just my third experiment that I'll be now discussing with you. So in the third experiment, what I did in the earlier case, you have seen that I had used one feature selection method. I had used only color feature, texture features. I had used only one classifier. Okay, that is SVM. So somewhere I actually restricted myself with those things. Okay, same classifier, my classifier was fixed. My feature selection PCA polling contribution was fixed. Okay, my features were also fixed, color features and texture features, right? So what I did in this experiment, in this third part of my work, what I did, I actually increased one more feature. We have included HOS feature, and we with that we have created now total 7 sets of feature combinations. Only HOS feature, only texture feature, only color feature, then HOS plus texture, then HOS plus color, then texture plus color, then HOS plus texture plus color. So total 7 feature combinations we have created. At the same, with that feature combinations, we conducted our studies, and there I come to know that we come to know that FC7 is having the highest accuracy. It means that all, if I include color feature and texture feature and the HOS features, my accuracy is going up to 98.29%. But if you look at the other accuracies with the FC1 to FC6 also, those accuracies are also more than 94%. That is also acceptable. It means that from this experiment, we are now, after this experiment, we were very clear that yes, it doesn't matter. I need not to have 859 features like that. I can only take the color feature, 172 color features, and my system will be still working good enough. Okay, I'll be only using my texture features, and that will be good enough for me. If I use only my HOS features, that will also be good enough for me. Or if I do the combinations, I'll be further improving my accuracy, but there won't be any loss to me. Okay, so if you want to reduce the computational cost, some restriction over that, limitation to that, you can reduce your features by taking any one of that FC1 to FC6. Okay, we also have done the classification performance we have measured here for the SVM only, first with the SVM classifier only, and that we did for healthy, mild, moderate, severe, and very severe multi-class classification, and with only for FC7 color feature, FC7 feature combination. And for that, you will see the classification accuracy. So if you just look at these values are very high now. These are very, means, no, there is whatever that earlier was 91%, 92% or something, that has now reached from above 95%. Okay, your area under curve is almost 0.92, sorry, 0.98 to 1. Okay, so if you just look at healthy, it is almost 199%, 98% accuracies has been achieved. Only the accuracy is very, in the case of very severe, it is 85.92. And I can tell you the reason for this, because we have taken very small number of data images for the very severe class, that was only 28. Okay, so with that, we also have calculated the reliability, and we calculate the system accuracy and reliability and put it here in the single table, and we come to know that if I do with the FC1 to FC7, if I do this feature combination change, my accuracy, system accuracy and reliability, say for reliability, for system accuracy, that change is spanning in the range, spanning for 5.36% only, while in case of reliability, it is that change in reliability for total 7 classes is only 4.55%. So it indicates that it doesn't matter that what feature that you are taking now. So you can choose any one of that, FC1 to FC7. You will be having, you will be sacrificing only 1 or 2 1 to 2% of your accuracy and reliability index. Okay, that if you can afford that loss of 1 or 2% of the accuracy and the reliability, then you can use the system with any one of that FC1 to FC7. Then in the fourth part, as I told you that I had not changed the classifier and the feature selection method. So in this experiment, what we did, we have changed the classifier and the feature selection method. We have taken here 3 best classifiers. Now taking these 3, why these 3 classifiers, we have taken support vector machine, decision tree, neural network, and here in the feature selection, PCA, feature discriminant ratio, and mutual information. We selected these feature selection methods and the classifiers based on the literature which is available. तो लिटरेचर में हमने ये देखा कि कलर इमेजेस के ऊपर कौन से क्लासिफायर सक्सेसफुल हैं, कौन से फीचर सिलेक्शन मेथड सक्सेसफुल है, और उसमें से बेस्ट 3 को हमने इसमें चूज किया है. इट्स नॉट, आई हैव नॉट chosen these things randomly because my images are color images, so I had I have studied the literature of the color images classification and feature selection for the color images, and from that literature only we have decided about these three classifiers and the three feature selection methods. Again, we conducted the experiment, and this time we have again changed the data set, because in the earlier experiment you have seen that hairy fever images were less, and due to that it was affecting the performance of our system. We have taken the images very severe 121, and for healthy and mild we have reduced. The reason is that mild and healthy images are very close. That is, it is really difficult to discriminate between them visually. Okay, but in order to in order to make the system to discriminate between the healthy and the mild, we have taken the less mild images, because we wanted to understand that whether it will learn from such a less number of the mild images correctly or not. Okay, so I will show you the results. You will be very surprised to know that in this case, in the all our earlier experimentation, what we were doing, we were actually manually segmenting the psoriasis lesions, and those manually segmented psoriasis lesions we are actually using for the feature extraction, selection, and then classifier. Okay, so manually segmented psoriasis lesions is actually, it is a tedious task. Manually अगर आप हर object को segment करेंगे, so it will take a lot of time. Okay, it will take a lot of man resources. So why it is not to have some automatic segmentation? So we have designed very basic Bayesian model based parameter. Bayesian model, अगर आप पैटर्न रिकग्निशन सब्जेक्ट अगर स्टडी करेंगे तो सबसे पहला जो आपका मेथड आता है पैटर्न रिकग्निशन में, दैट इज बेसियन मेथड. Okay, so we have used that Bayesian method, which is based on the probability. Okay, so for that also what we did, pixel based हमने क्या किया, pixels को classify किया based on the Bayesian model, and on the basis of that classification of pixels we have done the segmentation of our lesions in the color images. Okay, I will quickly go through this because the time is little less. So this is how you can see the images are now segmented here by using the Bayesian model. You can see image number A, image number B, that is segmented. Image number A and B is the segmented image. The background is black. Okay, so these are the sample results of the segmented images by using the Bayesian model. Okay, then now this is about what classifier and feature discrimination, feature selection methods that I use. So as I told you that features selection method that we have used is feature discriminant ratio. PCA में already आप लोगों को पहले बोल चुका हूँ, और उसके बाद हमने जो use किया है वो FDR है, feature discriminant ratio, which is very simple. That is, you have to see the intra-class and inter-class variances, and you have to take the ratio of that, and that will give you the FDR. Okay, and then there is a mutual information based feature selection. That mutual information is also again a probabilistic model, and it is actually based on the this equation that is given here. I will not discuss this equation. You people can easily find it in the literature. I want to show you the results. Okay, that what results we have achieved. So this is again brief about the decision tree and neural network. We have used the back propagation algorithm in the case of neural network for the decision tree classifiers. If it is actually based on the if and then rules. Okay, and we have designed that if and then rules for different classes derived from the different from the build tree to predict the class level of the test data. So that is what exactly we did. So now we have created total 9 CADEX systems here. One CADEX system, SVM with PCA, then SVM with FDR, then SVM with MIFS. Means SVM classifier के साथ तीनों feature selection methods को ले लिया, फिर उसके बाद decision tree को तीनों feature selection method के साथ लिया, फिर neural network को तीनों feature selection method के साथ लिया. ऐसे हमारे total 9 classification CADEX systems बन गए. Okay, and we have calculated the average accuracy for all that 9 CADEX systems, and that in this you just look at this bar chart. Now you just find out what is the highest accuracy. Highest accuracy, average accuracy is coming for as 99.84%, and that is coming for SVM and FDR. It is not coming for SVM and PCA. Means whatever we are doing earlier with the by following the SVM and PCA, that was not good enough. Okay, the system can further be improved if I include FDR instead of PCA. Okay, if you look at the accuracy at NN and FDR also, that accuracy is also higher, and it is 99.701%. Even if you look at the accuracy at NN and neural network with the mutual information, that is also having an accuracy of 98.95%. So all this CADEX system with all this classifier and the feature selection methods, if you just look at this, all the accuracies, average accuracies are more than 95%. It means that all these classifiers are able to classify the classification of this 5 classes of the psoriasis based on the different feature selection method. So from this experiment, we are able to understand few things. First thing is that क्लासिफिकेशन मेथड गलत नहीं है. एसवीएम से अगर काम हो रहा है तो वही काम एएनएन से भी हो रहा है, वही काम आपके डिसीजन ट्री से भी हो रहा है. इट मींस आई एम नॉट डूइंग एनीथिंग रॉन्ग विथ माय एसईएम इंप्लीमेंटेशन. मैंने कोई, दिस इज कंफर्मिंग दैट थिंग. माय फीचर सिलेक्शन जो हम पीसीए से यूज कर रहे थे, अगर आप यहाँ पे एफडीआर से कर रहे हो या म्यूचुअल इंफॉर्मेशन से कर रहे हैं, तब भी आपकी एक्यूरेसी जो है वो इट इज कमिंग क्लोज टू व्हाट यू आर गेटिंग विद द पीसीए. ओके, सो इट इज इंडिकेटिंग दैट आई एम नॉट डूइंग एनी मिस्टेक. I had not done any mistake while implementing PCA. That is reaffirmation, reconfirmation, right? So this is exactly what we did in this experiment, and I come to know that yes, SVM FDR is having the highest accuracy. It means that it is not only PCA that is giving me the best result. Yes, there is another feature selection method which can also give me the best result. Okay, so this is sensitivity, specificity, class accuracy that we have obtained by using SVM FDR. And just look at the numbers. Just look at the numbers. Even though I have included only less number of sample in the case of mild, I am attaining the accuracy of 99.95% for the mild class. While for other class, my accuracy is 100%, 100%, 99.99%, 99.94%. It means for every class, and that too with the variation for the variation of skin samples. मैंने 65 पेशेंट से वो सैंपल्स लिए हैं, तो कुछ पेशेंट्स का स्किन ग्रे व्हाइट होगा, किसी का वेटिश होगा, किसी का ब्लैक स्किन होगा. उसके बाद भी मेरा सिस्टम जो है उसको परफेक्टली क्लासिफाई कर पा रहा है, आइडेंटिफाई कर पा रहा है, डायग्नोज कर पा रहा है. सो दैट इज एन अचीवमेंट. See, I am not showing you the total detailed results. I am showing you the average results, average accuracy, average sensitivity, and all that things. If I show you the detailed results, then that is because these experiments are very huge. But we are showing you the results in a very, what I say, extracted format, right? So by looking at this, you'll be now able to understand that yes, my CADEX system is now reached at the stage where it can be easily accepted for the clinical application. That's what exactly I wanted to tell you from this. Okay, so we also have performed the changing data size. As I told you, that experiment also we have conducted, and for that changing data size, again we are able, अगर हम data size को change करते हैं in और उसमें अगर हम average accuracy लेते हैं, still in that case also SVM FDR is having the highest accuracy of 99.87%, and that is inter-system accuracy. And then we also calculate the reliability, and reliability is coming as 99.99%, means 100% reliability that we are able to attain for our CADEX system when I am using SVM FDR as a combination of classifier and feature selection, right? So this is all we done, and this is the final just one sample result that yes, automated segmentation and manual segmentation के साथ क्या variation आया 9 CADEX systems में, that we have shown here. So you can also see here that yes, manually segmentation is being actually done by one of the expert person. So he has done the his job very honestly and very sincerely. That is why the manual segmentation results are good compared to automatic segmentation, because automatic segmentation method, whatever we have designed, that is based on probability. So that is not exact. That is not exactly having the close results with the manual segmentation. But yes, comparably the results are close, right? You can see if I talk about SVM FDR, अगर मैं उसमें मैन्युअली सेगमेंटेशन से करता हूं तो 99.95% मुझे एक्यूरेसी मिल रहा है, और मैं उसमें अगर ऑटोमेटिक सेगमेंटेशन के साथ इस CADEX सिस्टम को अगर यूज करता हूं, so my accuracy is coming as 99.84%. okay, So automatic segmentation mein it is giving me the better accuracy, right? But if you'll see in the all the CADEX systems, अगर आप देखेंगे compare करेंगे accuracy का, so the accuracy difference is very small. So that much accuracy difference you can afford, because your lot of manual segmentation में जितनी resource, जितना tedious वो job है, जितना full concentration उसमें लगता है, जितना human resource हम लोग उसमें involve करेंगे, उसकी जरूरत नहीं पड़ेगी. We can use the computer based automatic segmentation. That is better. So this is just my initial experiments where I use Bayesian model. Now we are using the deep learning models, and that is far ahead. In that case, it is giving far better results than manual segmentation also. Okay, so that is what exactly is there. So with this, I am done with my presentation. I will not go to my final part because it is again will take another half hour. So as because of the time limitation, I need to stop here. So I hope all of you must have liked my presentation today. I hope that you must have learned something from this presentation. I don't know whether you have learned the techniques or not, because that is not possible in just one presentation that you'll be able to.
Yes, sir. Thank you, sir. We have couple of questions.
Right. I will give that answer.
So first question is, can you suggest the language, programming language and tools for implementation?
This whatever work that I have presented to you, we conducted this work in MATLAB. This is because this was our initial work, but at present we already have moved from MATLAB to Python, and even we have also left the conventional machine learning now. We are not using SPM, FDR, and all that things because now this is an era of this is the era where we are not going to do the feature engineering. We have left it to the computer machines, because deep learning is now doing the feature engineering itself. It extracts the features, it learns from the features, it do the feature selection itself. So we are not spending time and energy and doing all that feature engineering. So what I suggest to the present participants, that they can think, they should not, if your data is complex, say that you are having thousands of data and lakhs of data, and the variation in that data is very, what I say, the difference between the data information is very small. In that case, I will suggest that you go for the deep learning, because जो डिफरेंस होता है डेटा में, वो डेटा का डिफरेंस अगर बहुत कम है तो उसको माइन्यूटली लर्न करना जरूरी है, एंड वो कन्वेंशनल मशीन लर्निंग में थोड़ा सा पुअर हो जाता है. कन्वेंशनल मशीन लर्निंग आर गुड वेयर द डिफरेंस बिटवीन द टू द इंफॉर्मेशन इज लार्ज. जैसे आप लोगों ने देखा एसवीएम में हाइपर प्लेन बड़ा होता है, मींस it is able to categorize the data when there is wherever it will find to increase the hyperplane, right? But अगर उसको वहां पे hyperplane को increase करने के लिए जगह नहीं है, if there is no case is there, तब आपको hyperplane आपका जो है वो non-linear होगा. And for that kind of non-linear classifications, I will suggest that you go for deep learning rather than conventional machine learning. So that is one.
Yes, sir. Thank you, sir.
Right.
The second question was regarding the same. Will
Okay.
deep learning help improve the accuracy, and what would be the data size of the
Required, right?
Yeah,
right.
yeah.
So obviously, as I told you, that deep learning will surely help you, because in deep learning, I don't need to do anything. You need not to do any feature engineering in the deep learning itself. Whatever the convolutional layers are there, okay. So those layers will be designed in such a way that they will be extracting the lower level features first, then middle level feature for secondly, and then higher level features in the last stage. And that is why the learning in the deep learning architecture is very fine, very accurate. I will say that's why it is called as deep. Okay. So in that case, when the difference in the information, if it is learned properly, then the classification is very correct. It becomes very good. So that's why the deep learning, I will suggest that yes, deep learning is good. And what was this next thing?
So the data size.
Data size, right?
Data size.
Yeah. So if you want your deep learning architecture to learn in a deeper sense, then of course you have to give as much as possible the data. So generally what I with my because I'm using the deep learning since last 3 years now. This work what I presented, we conducted it in the year of 2016 and 17. And after 17 we have left the deep conventional machine learning and we are using the deep learning now. And since after doing experiments on deep learning on different data sets, like I had done the experiments on CT images, psoriasis color images. We also have done the experiments on ECG data set, ECG signals, then EEG signals. And from that I come to know, from that I come to understand that कि आपका जो data size है, that should be almost आपको कन्वेंशनल मशीन लर्निंग में जिसमें भी बेस्ट रिजल्ट मिल रहा है उसका ऑलमोस्ट 10 टाइम्स आपको डेटा एक्स्ट्रा लगेगा इन केस ऑफ डीप लर्निंग. इनफैक्ट आई विल से दैट इफ यू पीपल आर डूइंग द इमेजेस, अगर आप इमेजेस पे काम कर रहे हैं, सो आई विल सजेस्ट दैट यू कीप योर डेटा साइज मोर देन 5000. अगर आपके पास डेटा उतना नहीं है, देन डू द डाटा ऑगमेंटेशन. दैट यू there is a data augmentation techniques are there in the deep learning where you can actually create from one image, you can create 10 variants of that image. Okay, 10, 100 and like that. So वैसे आप data augmentation करिए, but you increase the size. Reason is that your system, your deep learning architecture needs to learn more. Okay, as much as it will learn, it will give you the better performance. It will give you the better results. Okay.
Yes, sir.
Next.
Thank you, sir. With this, we are at the end of the session. We'll conclude the session with vote of thanks. I, Pranav Chipalkatti, on behalf of JSPM's Rajarshi Shahu College of Engineering, Department of Electronics and Telecommunication, heartily thank Dr. Narendra Londhe, sir, for sparing his time and sharing his valuable knowledge with us. He has beautifully explored the computer-aided psoriasis disease classification and severity detection. Thank you, sir. Thanks a lot for your time.
Thank you. Thank you so much. Thank you to the Rajarshi Shahu College of Engineering and Pune, College of Engineering Pune for inviting me. And I hope at least all the participants will, if they are going to conduct any research in the future, they will be seeing that yes, the research need to be conducted in layers. And while designing any system, they have to go in such a deeper sense that yes, it's not that easy task. You have to do many experimentations. You have to think wisely while designing your experimentations to ensure that your system becomes more reliable, more accurate. Okay, and do that things in stages, like what I did in my this 6 years of tenure, that I moved from one thing to another thing and then another thing to any research requires time. You cannot do the magic. It is not magical thing. You cannot do the things quickly. Okay, so I think that all of you, all the participants must have been benefited from this particular session of mine. So I thank all the organizers and the college for inviting me, and I thank all the participants to attentively attending the session. And I wish them all the success for. I wish all the success for the course as well as all the success to the participants in future. Thank you so much.
Thank you, sir.
Thank you, sir. Thanks a lot. I'm Dr. Swati Bisikar here. Sir, your valuable guidance.